In this video, we are going through the full Limpopo 2022 pre-trial examination maths paper 2 exam memo. Anyway, so this first question here says each child in a group of 4-year-old children was given the same puzzle to complete, right? The time taken in minutes by each child to complete the puzzle is shown in the table below. So basically, children that took between 2 to 6 minutes, it was 2 of them. Between 6 to 10 minutes, it was 10. Between 10 to 14, it was 9, going on and on and on. So the idea is here they're asking us how many children completed the puzzle for 1 mark. So obviously, you're just going to add up these numbers, you see. And you may actually want to do it in such a way that helps you to answer the follow-up questions. Like you see here, they're asking for the mean. Eventually, they're asking for the cumulative frequency column. You might as well do it's more like 2 birds in 1 stone type of thing. 2 birds with 1 stone, yeah. So you can add for yourself like an extra column here, and then obviously extra rows. Nothing fancy, nothing fancy. Just needs to work. But fortunately, on your answer sheet, you will have places. You'll have like a table where you can add these. So in this column here, we're gonna say cumulative frequency. So let's put here cumulative frequency. So the cumulative frequency is basically a way for you to keep track of how the numbers will be stacking up. You see, so in the beginning you just have 2 people, so you're going to put a 2 here, and then you add 10 people, you're going to have 12, plus 9 people, you're going to have 21, plus 7 people, you're going to have 28, plus 8 people, you're going to have 36, right? And then plus 7 people, you're going to have 43, plus 2 people, you're going to have 45. So this is telling you in total you have 45 children. Anyways, the next question says calculate the estimated mean time taken to complete the puzzle. So if you're going to calculate the average mean time, the estimated mean time, you're going to need to use your calculator. But before you can use your calculator, you need to work with the midpoints of each of these different intervals. You see, you need to work with the midpoints of each of these different intervals. So what I mean is between 2 and 6, the middle is like 4, you see, because you will say 2 plus the 6, you divide by 2, so it's like 2 plus 6 is 8, divided by 2 is like a 4. So here let me put here a column midpoint, because if you're going to work out the average, or the mean rather, you need the midpoint of each of these classes first, and then we'll just use our calculator. So for that specific method, I will show it to you just now. So the middle of 2 and 6 is a 4. The middle of 6 and 10 is 8. The middle of 4 and 14 is like what? That's like 24, right? Divided by 2, that's like 12. And then 18 and 14. What is 18 plus 14? My calculator, my brain does not want to work here. But it looks like it's going to be like 32. 32 in the middle is like 16, and then here is like 14, the middle is like 20. It looks like we're just jumping by 4 every time, actually. Yeah. So here it's going to be 24. Here it's going to be 28. Okay, so this is how you work out the mean, right? In your calculator, where is this calculator now? Ish. I literally had this calculator with me. Oh, there it is. It's literally in front of me. So that's kind of awkward. So this is what you do. In your calculator, these are the following buttons that you're going to press. So let's see here. 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 You are going to press, what are you going to press now? Yeah, so you're going to press shift mode, shift, right? You're going to press shift and then mode, and then you press mode. After pressing mode, you're going to scroll down. Scroll down. After scrolling down, you're going to click on where it says stat. After clicking there, it's going to show you frequency, and then you're going to turn it on. Because you switching on frequency allows you to do what? Yeah, it basically allows you to work with your table for you to get the mean. So you're going to press 1 to switch it on. After you switched it on, you are going to press mode again. After pressing mode, you're going to press stat. After pressing stat, you're going to press var. You see, after pressing var, you're going to put in the data in your calculator, because you see there's going to be x here, and then here it's going to be asking you for the frequency. You see, so the x refers to the midpoint, each value in the midpoint. You see, so obviously the values in our midpoints, its values like 4, 8, 12, going on and on and on. You see, 4, 8, 12, going on and on and on. And then the numbers you put is your number of children. So it's 2, 10, 9, going on and on and on. 2, 10, 9, etc. So in the calculator here, I'm going to put the midpoints first, you know, like one by one. You're going to be pressing the number, you press equal to, you put in the number, you press equal to, and then when you're done with all the midpoints, obviously you want to go back up in your calculator to the very first value, and then you go to a frequency, and then you put in your numbers there, 2, 10, 9, the 7. So you want to be careful when you do this, so that you don't find yourself making like a silly mistake, because obviously if you make a mistake now, it means like, yeah, you can't take that back. After you do all this, right, you press on again. You see, you're going to press on, the on button, right, the actual on button, and then you're going to press shift, then you're going to press the button one, the number 1 button. It has written stat, it has stat written at the top here. Shift 1, and then you're going to press var. So it's like var. It's like var here. After pressing var, you're going to go to option number 2. See, like this. And then after pressing option number 2, you're going to press equal to, which is going to give you 15.3. You see, 15.38 actually. So that right there is your average. It's all calculator work that you need to know. The next one says complete the cumulative frequency column in the table in the answer book. So we have just done it up here. So, you know, what I can label here is 1.3. You see, this here is technically for 1.3. And then let me just say here done. 1.4 says draw a cumulative frequency graph, which is an algorithm to represent the data on the grid provided in the answer book. Okay, so on this grid paper, right, it says here, so if you're going to draw your algorithm, right, the one thing that you need to make sure of is your scale, you see. So in terms of the kind of a scale that you're going to have, you can obviously base it on the values on your cumulative frequency column. So it's from 2 to 45. So counting in fives it's definitely something that makes sense. So let me actually make this a bit smaller. Move it to the. It doesn't want to move to the right. You see now. Anyways, so let's actually do this. Let's actually do it like how now? Like this. Yo, gentlemen. Zoop. Oops. Doesn't want to do. So let me label it from here. I'm going to make this a 0. And then every 3 blocks, I'm going to make it. No, I can actually just, let me see here. 1, no. 5, 10, 15, 20, 25, 30, 35, 40, 45. Can do in threes. Let's see. 5, 10. No. Why do I have to start from here in the first place? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Oops, too far. 5, 10, 15, 20, 25, 30. It's not working, my guy. It's too small now. You thought you were smart. Now look. Ish, bring it down here. No. Come on. No. I want to move it down, bro. Move it down. So 0, 5, 10, 15, 20, 25, 30. And I will just have to make a plan here. 35, 40, and then up here is 45. Okay, so we can draw our ogive. So let me label this. Labeling this, we're gonna have 0 here. 5, 10, 15, 20, 25, 30, 35, 40, 45. You see, 45. And then this is like 0, 5, 5, 10, 15, 20, 25, 30, 35, 40, and then 45. And then what? Why this dot's not, not lining up nicely. It is what it is, it's fine. So when you plot the points on your ogive, right, you need to use the values on this part, and then you need to use your values over here. So 6, you'll have to put 2 as the y value. So 6 will be like somewhere there, and then 2 will be like somewhere over there. See, put a dot there. Hey, and then what do we have? We have 10 and 12. 10 and then 10, that's like somewhere there. 11, 12 will be like somewhere there. Yo, it looks steep, yo. And then we have 21. And then we have 21. 21 is for the next one. It's 21 and what? 21 and 14 actually. 21 and 14. So it's like 14 is like somewhere there, right? 21 is like 21 is like somewhere over here. Yeah, this ogive is pretty steep. Like it looks a bit steep. It looks scaringly steep actually. But it is what it is. It is what it is. And then here it's like 18 and 28. 18 and 28. Where's 18? 18 would be like somewhere there. 28 would be like for the 30, somewhere there. And then you have 36 and 22. 36 and 22. So it's like 20 is here, right? 20, 22 and 36. Yeah, 22. Yeah, 22 and 36. It's 22 over there. 36 is like somewhere over there. And then you have 43 and 26. So it's like 43 and what? What the? Yeah, 26 and 43. So 26 will be like, oh yeah, it has to go. 26 will be like somewhere here. 43 will be like just above the 40, which is like somewhere there. Make it a bit brighter. And then we have 45 and hypo. What did I just do? Yeah, 45 and 30. So the 30 is over here. Then the 45 is like all the way up there. So your ogive, right? You always have to try and make sure that it is grounded at 0. So here you can try and make sure that this maybe goes up somewhere there, So your ogive is going to do something like this. Yo, yo, yo. Something like this. Let me actually take it from the top. There you go. There you go. Perfecto. And there's your archive. So this last question says use the graph to determine the median time taken to complete the puzzle. So the median time will be in the middle of your data. So when I say in the middle of your data, it's basically going to be in the middle of 45. I mean 45 as in, you see there's 45 children, right? So the position of the median, you can use this formula. Position of median is going to be equal to 1 over 2 and plus 1. We can say 2 over 4 is the same thing. So here you have 45 children, right? 45 plus 1 divided by 2. Whoa, calculator, don't fall now. 45 plus 1 equals divided by 2. You're going to get 23. That's the position of the median. So what that means is in your data, you need to go where 23 is. So this is like 20, right? 21, 22. 23 will be like just after the middle. And then you trace it to your data, to your graph, I mean. Trace it, trace it, trace it, trace it, trace it, trace it, trace it. And then when you bring it down, you're roughly getting 15, which is good. You see. So you can say the median there is plus or minus roughly 15. You can just say approximately 15 actually. Approximately 15. Okay, question number 2 says the following. Learners who scored a mark below 50% in the mathematics test were selected to use a computer-based program as part of an intervention strategy. This seems very familiar. It says, on completing the program, these learners wrote a second test to determine the effectiveness of the intervention program. The mark as a percentage scored by 15 of the learners in both tests is given in the table below. Okay. So we have test 1. These are the marks of the learners, learner number 1 until learner number 15. And clearly for test number 2, it looks as though the marks did go higher because, I mean, like for each individual test, it looks like everyone scored higher than the first test. Not necessarily everyone, but I mean, that's actually no, look, okay, except for this person, maybe. The rest, it looks like they went higher. So this represents X, this represents Y. And the idea here is here it says determine the equation of the least squares regression line. So your equation of the least squares regression line is this equation. Y is equal to A plus BX. You see, there we go. So the idea with this equation, Y is equal to BX, is that, I mean, A is a specific value, B is a specific value also. So with that being said, right, what you want to keep in mind is the following. For you to get A and B, you're going to have to use your calculator. So in your calculator, this is what you're going to put in there. You're going to put mode and then stat and then the second one, you see. So here this is mode, right? And then you go to stat and then you go to A plus B X, you see. So after doing that, it's going to give you 2 columns to put stuff in. There's going to be one for X, then there's going to be one for Y. One for X, one for Y. There we go. And then from here, you are going to do the following. What are you gonna do? After putting in the data, right, you're gonna press the on button. You're gonna put in your data, and all that. You press the on button, then you press shift and then the number 1 button. And then after pressing the number 1 button, you press reg, for least squares regression line. After choosing reg, you have to choose A, of which in our case here, right, with all this information that we know, if you are going to put all this in a calculator, let's see what we're getting. We're getting here for A 12.44, and then for B, you do the same thing. You see, for B, do the same thing. We're getting here 0.98. There we go. So here you're going to say, therefore, Y is equal to 12.44 plus 0.98 x. There we go. We love to see it. So that's what you would do for this particular question. 2.2 says the following. The learner's mark in the first test was 15 out of a maximum of 50. Write down the learner's mark as a percentage. So if a person is going to get 15 out of 50, for you to write this as a percentage, you have to multiply it by 100. Of which, when you do that in your calculator, it's going to give you 30. See, this is 30%. Moving on. The next one says, predict the learner's mark. Predict the learner's mark for the second test. Okay. Give your answer to the nearest integer. So this specific learner, for the first test, they got 15. So if you're going to predict their mark for the second test, they need you to make use of your least squares regression line, because your least squares regression line is what allows you to be able to estimate values depending on what they give you. So remember, we say test number 1 is being represented by x. Test number 1 is being represented by x. So in this case, if this person got 15 for test number 1, means that wherever x is, right, we're going to drop 15 over there. So this is going to be y is equal to 12.44 plus 0.98. The value of x here, you're going to drop in as 15. And then obviously when you put all this into the calculator, 12.44 plus 0.98, you're gonna have 15 over here. This is 27.14. 27.14. Perfect. So with all this being said, right, we would now be able to, but they said to the nearest integer. So here you're going to say, therefore, it is equal to 27. You see, that's the mark that this person would get. They would get a mark of 27. And that's what you would leave it as, since they said they want you to write it to the nearest integer. So with the next one, which is question number 2.3, they said here, wait a minute, we have to be careful here. They said, what did they say here? This is just, oh, these are already in percentages. Oh, so if this one says the percentage is 30, yeah, here we have to be careful, right? Because this 15 is the actual mark, not the percentage. So the percentage is actually at 30. In the calculator, let's see what we're gonna get here. In the calculator, we are getting 42.41 actually, 41.84. And then obviously when you round this off, this is going to be equal to 42. So for 3 marks, right, we need to carry on. For 2.3, it says, For the 15 learners right above, the mean mark for the second test is 45%, 45.67. So that's the average. Wow. And the standard deviation is 13.88. Oh, this is so familiar. Looks like something in the statistics course, actually. Then he says that the teacher discovered that he forgot to add the marks of the last question to the total mark of each of these learners. Yeah, this question is definitely in the course. That's why it looks so familiar. And then it says, yeah, the learner discovered that he forgot to add the marks of the last question to the total mark of each of the learners. No, the teacher discovered that he forgot to add the marks of the last question to the total mark of each of these learners. Then it says all the learners scored full marks in the last question. And then it says here, when the marks of the last question are added, the new mean mark is 50.67. What is the standard deviation after the marks for the last question are added to each of the learners total? This is quite an interesting question. I mean, like, it's definitely an interesting question because you'd be thinking to yourself, wait a minute, standard deviation, dang it. So your standard deviation, you have to remember that your standard deviation is the average. It gives you an idea of how far each piece of data is away from the mean on average. So what that means is if our average is like 45.67, right? Your average is 45.67. What they're going to do is they're going to check from 10 to 45 point something, what's the distance? They write it down. And then from 18 to, wait, we're using the second test, yeah. From 33 to 45, they check what the distance is, they write it down. From 21 to this, they write down the distance. From 32 to this, they write down the distance, going on and on until you're done. And then once you do that, they add it up and they divide by how many values you are dealing with. That's your standard deviation. It's just to give you an idea of how, on average, each value is away from the mean. So if each number moves up the exact same value upwards, it means that the distance from the mean will still remain, what you may call the distance between each piece of data in relation to each other is going to remain the same, because if you, let's say, have the number 20 and the number 28, if you add 5 to this number, before you add anything, right, between 20 to 28, there's a gap of 8. But then if you are to add 5 to this one and you get 25, and you add 5 to this one and you get 33, the distance is still 8, you see. So that's the idea here behind us saying that if every mark moves up by the same value, the mean is going to change, yes, but the standard deviation is going to stay the same. The reason the standard deviation stays the same is because each piece of data moved up the exact same value upwards. So in terms of, let's say, like how spread out each piece of data is from each other, or how far apart each piece of data is from the mean, that number is still just going to stay exactly the same. 2.3.2 says, what is the total mark of the last question? Well, if you're going to get the total mark of the last question, you're going to need to compare the averages. So average number 1 is 45.67. Average number 2 is 50.67. So the idea is, you see, you want to compare what the difference is between the mean first. So 50.67 minus 45.67, right? That's giving you a distance of like 5%. You see, this here minus 45.67, 50.67 minus 47.67. This is giving a 5. So with this being said, you need to keep in mind that we know that it is a 5% increase. See, so what we know is the test is out of a total of wait a minute. Oh, this is gonna be interesting. Well, the last question contributed 5% to what was originally there, you see. So what we know is if you take 50% and you add what you may call, I'm trying to not overcomplicate this question because it's a 2-mark question anyways, right? So you really don't want to overthink it. I mean, they did ask what is the total mark of the last question? It's 5%. But then now, do we just leave it like that? Yeah, I mean, like this is good enough because if they ask what is the total mark for the last question, it's just 5%. Remember, these marks here are already in percentages, you see. So if each learner's mark moved up by 5%, it means that the last question was worth 5%. So this one you can just leave it like that. Question number 3 says the following. In the diagram, A, B, C, you have A, there's nothing given there. B, nothing given there. C, you have something. D, you have something. And then they say these are vertices of a trapezium, right? Yes, because you have parallel lines there, parallel lines there. So with everything being said, right, this is what you need to keep in mind. It says here, these are vertices of a trapezium with A and B, with AB parallel to DC. And they said E is -2 coordinate 0. And then they said here, yeah, it says here A, B, C, D, yada, 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 vertices of a trapezium. These are parallel. You have E somewhere. It's a x-intercept of the line AB. Then it says the inclination of AB is alpha. And then it says K lies on the axis. Yeah, K lies on the axis here, on the y-axis rather. And then it says, and KBE is equal to theta. KBE is equal to theta. Okay, that's interesting. So for 2 marks, it says we need to determine the midpoint of EC. The midpoint of EC. So if you look at the line EC, I mean, like, it's gonna be like somewhere there. Yo, brother man, what's going on? You know, like hectic. Yeah, eh, somewhere there. I wish I could have just made it a straight line, but hey, it does not want to do. But I think you get the idea. This is where EC would be. Let me actually make it maybe a bit smaller so that I can just draw a bit better. EC. Yo. Ah, not too bad. So E and C, they want us to get the middle. The middle may just be on the y-axis, we don't know, but getting the middle, you're just going to use the midpoint formula. As straightforward as that. You see, so here you're going to have x1, y1, x2, y2. And then here you're going to have -3, -0, right? -3, -0. Then you're going to have 2 minus -2. And then you're going to have -3 over 2 plus 2 is a 4. And then, yeah, you carry on moving forward. Wait, that's the gradient, bro. Come on, bro. Bro. That's a weird example. That's a weird way to flop. I literally wrote down the gradient formula, and I wrote it so confidently. But anyways, this is the midpoint formula. So we're gonna say x1 plus y1. So it's -2 plus 2. -2 plus 2. And then you're gonna have 0 plus -3, which is, -3. -2 plus 2 is a 0, divided by 2 is a 0. So it's like 0 here and -3 over 2. Yeah. -3 over 2. There we go. Moving on. Oh yeah, so now we do know that this is actually the middle. Is it -2 over 3? -3 over 2 actually. -3 over 2. And then it says we need the gradient of DC, right? Where is DC? There's D over here, there's C over there. The gradient, we're just gonna use the gradient formula. Now we can use the gradient formula. See, M is equal to y2 minus y1, x2 minus x1. And then obviously you can just say here minus 3 minus negative 5. And then 2 minus negative 2, which would be a plus, right? And then it's like negative 3 plus 5, which is like 2 and 4. That's a half. Gradient is a half. You get your 3 marks, you keep it moving. So it means the gradient of AB is also a half. Unfortunately, because you have a coordinate that the line passes through here, you can always work out the equation of AB if they ask it. And the next question here, they're asking for the equation of AB. What a wow. So the gradient of AB, we already know it's a half because AB is parallel to this line here. Remember, parallel lines have the same gradient. So if you have the gradient of one of the lines, you automatically have the gradient of the other one. So what you may always need to keep in mind is this equation here, y minus y1 is equal to mx minus x1. This equation here is very useful because it will get you the equation of your straight line. Gradient is a half. The coordinate we can sub in here is e. You see, the coordinate of e we can I made a mistake. It's not 0 and negative 2, it's negative 2 and 0. Negative 2 and 0. And then you're gonna have your x1, y1. So when you see x1 here, you're gonna have to put a negative 2 and minus negative 2, so it will be a plus 2. And then y minus y1, right? That's gonna give you, what is that gonna give you? It's gonna give you a 0, y minus 0. And then here you're gonna have a half multiplied by x, right? It's like a half x. A half multiplied by 2 is like 1, and this is y. There's your equation. So we already know that this point is also 1. And the one thing I'm going to take note of is, depending on whatever it is that I'm doing, right? What I'm spotting, whatever we're working out, we're just putting it onto the sketch as well, so we can use it, you see. They want us to give the size of theta. So here you can see the one thing that's already standing out for me is the fact that they're asking for theta here, right? But this is a 90-degree angle. You know, that's just where my brain went. Because if this is a 90-degree angle, this one, we have a right angle triangle here. And inside this right angle triangle, we can see that theta is an exterior angle. So we might as well get alpha, because alpha plus the 90 is what gives us theta. To confirm that, you can check in the rest of the questions, right? There's no way where they are going to be asking us to use alpha for anything. So we might as well get a value for alpha since we need it now. But here we can safely say, firstly, theta is going to be equal to alpha plus 90 degrees. This is analytical geometry, so you don't necessarily have to give reasons. But just for the vibes, you can, because, you know, why not? Exterior angle of a triangle. Now, to get alpha, we can see that this is an angle of inclination. And anytime we need to get an angle of inclination, we can use the tan formula. So we can just say here tan alpha is equal to m, which is going to be a half. And then to put, this is a half, right? So that's like gradient is a half tan theta. And then you're going to do shift tan. So shift tan a half. What are you going to get now? Shift 10 and a half, right? Shift 10 and a half. In your calculator, this is giving you 26.57, which is good because it's really not it doesn't seem like a number that's like far-fetched. You know, it kind of just blends in, you know, it kind of just fits in nicely. So that's nice. So this is 26.5, what? Yeah, 26.57. So here you can then say, therefore, theta, how many marks did they ask us for? Did they give us, they're giving us only 3 marks, you see, because this is not a difficult question. Theta is going to be equal to 26.57 plus the 90. And there we go. So these questions, I don't know, they just look so familiar. Hey, yeah, it is what it is. Let's just keep moving forward. The next one says we need to prove that AB is perpendicular to BC. So AB being perpendicular to BC, there's AB here, BC. Oh, we need to prove that this is a 90-degree angle. And to prove that lines meet at an angle of 90 degrees, you can just use their gradients. Unfortunately, we have all the information we need to get the gradient of the other line. You see, the x value here is a 0, the y value is a 1. So we have the coordinate of B. We also have the coordinate of C. So getting the gradient of AB is not a problem. We already have, getting the gradient of BC is not a problem because we already have AB. So let's see, if you're going to prove that lines are perpendicular, you need to prove that the gradient of the one line multiplied by the gradient of the other line is equal to -1. So in this case, we're using the gradient of AB and the gradient of BC. So the gradient of AB and the gradient of BC, you need to keep in mind the following. The gradient of AB we already have. It is it a positive half? Yeah, it's a positive half. The gradient of BC is missing, but we can get it, you see. The gradient of BC is just going to be equal to, y2 minus y1 and all that. So here we can say -3 minus 1. So it's going to give us here -3 minus 1. And then here we're going to say 2 minus the 0. 2 minus the 0. And then you're going to have here minus the 4 over 2 minus 2. Now, all this being said, right? All this being said, the gradient of the first one is a half. The gradient of the next one is -2. As long as you're sure that this equation balances out, you can say therefore AB is perpendicular to BC, because perpendicular lines have gradients that should give you a product of -1 if you multiply them. 3.3 says the following. The points EBC lie on the circumference of a circle. Determine the center of the circle. Line EBC. So this is a very specific question, right? So they're talking about EBC. They're saying there's a circle that goes around those points. The center of that circle would automatically be this point. The reason why this would be the center of the circle is because this is a 90-degree angle. So this 90-degree angle is subtended by the diameter of a circle. So if this EC is what we see as the diameter of our circle, it means the middle would need to be the center. And we're seeing EC as the diameter because a diameter will always be subtending a 90-degree angle. So if a circle goes around here, this line would be the diameter, and this is the center. What we know about this point is that the x value is 0, but the y value is -3/2. So with all that being said, we can move on to the next question. Let me write here 0, -3/2. Next one says the equation of the circle we should determine the equation of the circle in this format. Well, we have the center, which is we have this x value and we have this y value of the center. Getting the radius, we can see all we have to do is to get the distance between one point and this, or one point and that. It's up to us. So let's use E and the center here. So the distance of that, if we think of our distance formula, so let's put here, let's just put radius actually. Let's actually write it as R. R is going to be equal to the square root of the following numbers. So you're going to have two numbers here squared, you plus two numbers here squared, two numbers there squared also. The two coordinates we're using, right, it's basically E and this middle. So for the first bracket, we're going to say 0 plus, we're going to say -2 plus the 0. The other one, we're going to say 0 plus, we minus inside the brackets actually, yeah. So if we're going to be minusing, we're going to say here -2 minus the 0, and then 0 minus the -3/2. So how is that going to come out? So we say it is going to be -2 minus the 0, and then it's going to be 0 minus the negative 3 over 2. So a minus and a minus will give us a plus. All this, you really don't have to stress too much about it because you might as well just throw it into your calculator. So throwing it all into a calculator, let's see what we are getting. Well, let's just take it a step further actually, because why not? This is going to be a 4, no, negative 2 squared, right? Which will give us a 4. This is 3 over 2 squared, right? This one is going to give you a 4. This one is going to give you 9 over 4. And then obviously 9 over 4, if you are going to add the 4 and then you square root it, let's see what you get. 9 plus 9 over 4. Okay, 9 plus 9 over 4 is going to give you, I mean, it is going to give you what it is going to give you, but let me actually just be careful here because I'm trying to see if what we are doing here is vibing. Let me just double check here nicely. Yeah. Negative 2 minus 0. 0 minus this. So the square root of that number is just going to give you, what is this? 5 over 2, which is definitely fine. So the r is 5 over 2. So if our r is 5 over 2, I mean, it means that therefore the equation, you're going to have your x minus, remember, the x values are 0, the y value is negative 3 over 2. So because it's negative 3 over 2, you have to write it as a plus here because you always do the opposite. But here, you just square this. Our r is 5 over 2, right? And then you have to square it here because that's the format. Now, if you leave this like this, it's 100% fine. It's just a 0 anyways, you see. That's how you work out question number 3. Question number 4 says, in the diagram, this question looks familiar again. Yeah, see. These are all questions from other past papers, like legit. But anyways, it says, in the diagram, the circle is centered at M. Okay. Circle is centered at M. The radius km is produced to L. So radius km is produced to L. And then it says a point outside, no, it's produced to L, which is a point outside the circle such that kml is parallel to the y-axis. And then it says here, LTP, LT and P is a tangent to the circle. Automatically, we know that if this is a tangent to the circle, right, then this line has to be a 90-degree angle because a line coming from the center of a circle will always bisect a tangent at an angle of 90 degrees. And then it says here T is this coordinate given, -2 coordinate B, and then you have S also. Where's S? Just this point over here. So obviously them telling us that these are equal, this is obviously very important. It's going to come in handy. But let's see what we can do. For 4 marks, they say given that the radius of the circle is 5, show that B is equal to 4. Well, if this distance is a 5, I mean, like we can just use the distance formula to show that B is a 5, you see. Because this we can label it as x1, this can label it as y1, x2, y2. You see, we can definitely do that. So all this being done, the one thing we need to keep in mind is the following. You see, what do we need to keep in mind? We need to put distance, right? So let's put here distance. Distance. Yeah, so the distance of what? Let me just write the letters. It's basically TM. I don't even know I'm writing the formula first, but here it is. It's fine. TM here is going to be equal to square root of this whole thing here. Square root. It's like x1 minus x2 squared. Y1 minus y2 squared. It doesn't matter if you start with 1 or 2. It really doesn't matter as long as they match. You see. So in this case, we're going to say -2 minus 2. So it's going to be like -2 minus 2 squared. And then 1 minus b. 1 minus b. 1 minus b. There we go. And then there's like what? Negative 4 minus, no, minus 2, it's like minus 4 squared. Then this we can actually FOIL it out. 1 times 1 is 1. 1 times negative b is going to be negative b. But you can have that twice, and then here b squared. Okay, actually no. If you FOIL it out, you're just creating problems for yourself. You might as well leave it like this. You see, and you'll see why just now. Remember, this is a 5. It's equal to 5. So now when you're working out for b, you can actually just square both sides here. Square this side, square this side. And then you're obviously going to get 25 over here. The square root cancels that. Negative 4 squared is a 16. The reason why I say don't remove the square is because you can still just work it out like that. You see, the 4 goes 25 minus 16, right? It's going to be a 9. Now to get rid of the square root, you need to make sure that to get rid of the square, you need to square root both sides. But be careful to make sure that your answer has plus or minus. Otherwise, you will only get one value for b, which is not necessarily true, you see. So in this case, the b goes here. You're going to say that you're going to split up your page into 2 places. You see, one of the sides you're going to have a 3 as a positive. The other one you're going to have a 3 as the negative. You see, so here working out b, it comes over to this side. This goes to the other side. 1 plus 3 is a 4. Then here goes over to that side. It's going to be negative 2. So this one you rule it out because you see b has to be a positive y value. So positive 4 makes sense. So the reason why you're also getting a negative 2 there is because you see, if you go downwards, right? No, it doesn't make any sense. Yeah, it doesn't make any sense at all. I think you'll probably be getting a negative 2 if you were going, let's say, let's not overcomplicate it. If you were maybe going this direction, or if you're going that direction, yeah. Because you see, if you're going like this, if this is 90, somewhere here, the y value is going to be a negative 2. And then, no, the x value is a negative 2, and then the y. Let's not overthink it, because if you would also go this way, I mean, like, you're bound to also have like a negative 2 somewhere here as the y value. Or somewhere, no, dude, let's just leave it. Let's not overthink it. But we have our answer. Let's move on. And then here it says, determine the coordinates of k. And it's a 2-mark question. It's a 2-mark question because they know we really are not doing nothing crazy here. If you're gonna get k, right? Determine the coordinates of k. Oh, the coordinate of k. Well, the fortunate thing is k is a point that is like directly under m. So, because remember, you see it's parallel to the y-axis. So what we know is if the x value here is a 2, the x value there is a 2 also. The y value here is a 1. The y value here is a negative 4. See? So with all this being said, we can just put our coordinate and get 2 marks because there's really nothing much to say. 2, negative 4. There we go. The next one says the equation, you should get the equation of the tangent LTP, right? Yeah, LTP in the form y is equal to whatever. Where's LTP? LTP. But at least we have this. Oh yeah. What's gonna make our life so much easier is the fact that we have B. Because as long as we have B, we at least have a coordinate that the line passes through. What we also have is a line that is perpendicular to L. I mean, a line that is perpendicular to TM. So we can get the gradient of TM. That can help us to get the gradient of LTP. And then once we have the gradient of LTP, we can then throw in a coordinate that the line passes through. And then we will be good to go. So with all this being said, right, let's see LTP. So we can say here we need the gradient of TM. The TM, yeah, TM. We need its gradient because once we get its gradient, we're gonna use this formula to get the other gradient. You see, we're gonna use this formula. m1 times m2 is equal to negative 1. So what we know is in terms of y values, right? We can say 4 minus 1. So let's do it 4 minus 1. And then we're going to say negative 2 minus 2. And then the gradient here, 4 minus 1 is a 3. This is going to give you a negative 4, like that. This is the gradient of the first one. So what we know is, remember, the gradient of Tm multiplied by the gradient of LP, whatever LP is going to be, LTP rather. Let's just call it LP, LP. If you multiply these two, they should give you a negative 1 because they're perpendicular. So because we know what the gradient of the first one is, negative 3 over 4, and we're trying to find the gradient of the other one, you have to divide both sides by negative 3 over 4. Negative 3 over 4. Like that. See? And then this we cancel out. This cancels that. This divided by this gives you 4 over 3 in your calculator. So now you can say, therefore, y minus y1 m x minus x1. And then you can throw in a coordinate that the graph passes through. Remember that coordinate is t, which is like negative 2 and 4. Just double check there. Yeah, negative 2 and 4. Now the big idea is gradient is 4 over 3. First x coordinate is a negative 2, so you can put, if a negative and a negative go there, that'll be a plus. Y minus 4. We're just having 4y now. This goes inside. It's going to be 4 over 3x. This goes there. It's going to be 8 over 3. This goes to the other side. It's going to be plus 4. Then it's like y here. Then it's like 4 over 3x. And then this plus the 4, what do you get now? You get something interesting, maybe you get something interesting, But obviously we need to double check with the calculator, otherwise we're not going to have a good time. So here we're getting here 20 over 3, which is fine. So that's the equation of your line. You get your answer and you keep it moving, We want the area of LPK now. Where is LPK? What is the LPK? So the interesting thing about them wanting the area of LPK, right? Let's put here LPK, paste. Crop. Whoa, why is it shrunk like this? It's looking weird, eh? Yeah, much better. So with what we know, right? We have quite a bit of information on this sketch. So if they're going to ask you for the area of LPK, let's see what that is. There's L here, P here, K here. So that being said, the one thing that, as I mentioned, this question does look a bit familiar. And I remember the one thing that stood out was the fact that you may want to look at this as the base. This line here. You may want to look at this as the base. Because if you look at that as the base, you can look at this as the perpendicular height. See, then you can get the area of a triangle. Now the idea is, fortunately, you have the equation of LP, the LTP. You have the equation, you see? It's over here. Now what you know about L is, well, if you think of it right, here you have a base, you have a perpendicular height. Perpendicular height. Now, for you to make use of this information, right? I mean, your perpendicular height is not difficult, because what you know is you can just get the coordinate of P, and then you can just get the distance between here going straight down to this X value, which is at 2. So if you know the X value of P, and you compare it to this x value here, you can get the distance. That will be a perpendicular height. For the base, we already know what k is. K, we got it to be x is a 2, y is a -4. 2 and -4. 2, -4. And then what will happen now? And then from there, the one thing I'm thinking of is, I mean, we have the equation of LTP. It can definitely get us L over there, but then how can we eventually get P? So let's check what other things they made us get here. Coordinates of K, fine. And then here, given that, oh, okay, wait, that was not gonna help us now. Oh, wait a minute, the midpoint theorem. Ha 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 ha. So we need the coordinates of P. We can get it using the midpoint, no, not the midpoint theorem, the midpoint formula. Because you see, we have K here and we have S. So we can get this one. And then for L, we already know that we have the equation of LTP. So we can just put in the x value of 2 in the equation, and then we'll have the y value. Because if we have L and you have P, you're good to go. Remember, this is not a 7-mark question for nothing. You see, so let's get what we need to do. Let's do L first. Using L, what we already know is that this is the equation, right? That also passes through L. So this equation, what we're gonna do is we're gonna put the x value is a 2, right? So this is like 4. Let's put like 4 over 3, 2 here plus 20 over 3. This is like what, 8 over 3 plus 20 over 3. This is like 28 over 3. You see? So just because it's a fraction doesn't mean, it's wrong. And then the value of P, you can use the equation, the midpoint equation, the midpoint formula, where we know that the x value of the midpoint is equal to x1 plus x2 over 2. The y value of the midpoint is equal to y1 plus y2 over 2. And then with all this being said, here, the x value we have, right, it's -4.5. So -4.5 is going to be -9 over 2. And then we have one x value here, which is a 2. The other one we don't have. So you leave it open. We're trying to work it out. For the y, you do the same thing. -6 is equal to y1, which is going to be -4. -4 is y2 over here times 2. And then you're going to, here you can see, if this is a fraction already, you just cross multiply. You see 2 times the value on top there, 2 plus x2, 2 times the value on top there, -18. And then 4, 2x, -18. And then here also goes in, that's like negative what? -22. And then divide by 2 on both sides, divide by 2, divide by 2. That's like -11. X, the second one. Perfect. Here, 1 times that is going to give you -4 plus y2. 2 times -6 is going to give us -12. The -4 goes over, you're going to get -8. And this is your y2. Therefore, your coordinate of P is going to be -11 and then -8. Whoa, come on. So once you have P and L, once you have L and P, you're good now. Because now you can say, therefore, the area is going to be equal to a half. Remember, the base is the distance from here all the way down. So remember, the distance from here until down there, you're going to say the y value here minus the y value down there. So it's going to be this. If you're minusing, it's not over 3, bro. Over 3. So that distance of the base is going to be the y value up here minus the y value down here. So this minus a negative number, it means that you're going to be plusing. So this is your base. Your perpendicular height, you're just comparing these two x values. You see, there's a negative 11 over here. Here's the coordinate, right? So if you're going straight that way until this point, it's from negative 11 going straight down to the other side until positive 2. So it's like 2 units and then 11 units. You see, so it's like 13 units in total. So you want to keep in mind. You see, 13 units. 13. Now, all this in your calculator. Let us see what we shall get. So what we're getting here is quite interesting, obviously, because, yeah, that's just how it is. It is interesting. So we're getting here 269 over 3, which is equal to 86.67. Nice. Now they said whatever they're saying here. They said another circle with center, another circle with this equation, right, is drawn. Determine with an explanation the values of n for which the two circles will touch each other. Okay. It's quite interesting. So what we know is that this circle, this here, should give us the x value of center. You see, x value of center. And then once you have the x value of your center, you can keep in mind that this original circle also has the same x value. That's what you want to keep in mind, you see. Because if it's a negative 2 over here, it means it's a positive 2 on the actual Cartesian plane. So what we know is that this circle that they're talking about, right, it has a radius of 5 also. Because you see, this is standing in the place where r squared would go. So they're literally talking about, let me see what the mark allocation is here. It's a 4-mark question. So if you think of it nicely, right, n represents the y values of the center. So if they say determine with an explanation the values of n, or with an explanation, so the 4 marks comes from the explanation, basically. Well, in the sense that you're going to write out what you're going to write out. Say what you're going to say, but your explanation is what needs to back you up. It says another circle with center this is drawn, determine with an explanation the values of n for which the two circles will touch each other. So the idea is, if these circles will touch each other, you have to keep in mind that there are only, two scenarios where they will not touch each other. Let me repeat. With our sketch, there are only 2 scenarios where our circles will not touch. And this is what I mean. Firstly, we know that the centers of the circles is the same. So the idea is, if we're going to work out the value of n for which the circles will touch each other, we have to keep in mind that the first time they will touch is like when the one circle is like over here with the center somewhere there, or when it is down all the way here, you will still have a specific center somewhere there. Now what we know is the radius of this circle that we're talking about is still just 5. So this distance here is 5 upwards, and then here from here going there, the distance there is just 5 downwards. So with all that being said, right, 5 units. So with all that being said, what you need to then keep in mind is the fact that this here, this center and this center, you can easily work it out comparing these distances. If it's 5 units upwards, 5 units again. So you see from 1 unit, so this is like a y value of 1, right? If you go 5 upwards, you're at 6. And then if you go 5 upwards, you are at 11. So what we can see is n, as long as our y value is an 11, it's fine. But then we can see that for these circles to also be touching, the y value needs to be below 11. The y value needs to be below 11, but then once you reach to the other side here, the y value needs to be above a certain number, or smaller or equal to 11. And then when your circle is all the way down here, right, the y value here, it should not go below this y value. So to determine this y value, we can see, you see the y value here is a 5. So if you go 4 or 5 down, this is like a 1, right? If you go 5 downwards, you're at -4. 5 downwards, you're at -9. You see? So you should not go below -9. So n, the center of the center in terms of the y value should be bigger than or equal to -9, and then it should be smaller or equal to 11. So with all that being said, right, we need to determine the following. When I say we need to determine the following, this is what I mean. Oh, they said we need to give an explanation. Well, everything I was saying is practically the explanation we're going to write down here, but we're going to try and put it in simple words. So we can say something like the new circle. We can actually say that it is identical to the other circle. It is identical to the original circle. Is identical to the original circle. That's the first thing, right? Secondly, the y, the highest possible value for n, the highest possible value for n is 5 units away. No, not 5 units away, 10 units away. 10 units away from 10 units away from it's 10 units away from this center, from the center of the original circle. 10 units away from the center of the original circle. 10 units away from the original circle, and the lowest value of n is 10 units away from the center. There we go. So it's quite an interesting way to think about it, really. But the one thing we obviously can see kind of like stood out in this kind of a scenario is the fact that, you know, that the circles are identical anyways. You see, the circles are identical. You know, the centers of the two circle line, the same vertical line. You see, the circles are identical. And apart from them being identical, you see, the last thing you can drop here is that the x values, the x values of the centers are aligned. There you go. Question number 5. It says, without using a calculator, write down the following expression in terms of sine 11. It's not that bad. So this, we know that sine 180 minus plus 11 is going to give us 191. So if you're thinking of the cast diagram, what we already know is that 180 plus puts us in this quadrant, right? And in this quadrant, 10 is a negative. So this is going to give us negative sine 11. Because you see, you're still going to use your sine because of the 180. In this quadrant, 10 is a negative. 10 is a positive. Oh, why am I yawning and talking at the same time? 10 is a positive in this quadrant, so you put negative for sine. The next one, okay, this is just double, it's just double 21, it's just double 11, so this is just double angles. So if you're going to write it in terms of sine, you can just use this double angle. You see, 2 alpha is going to be equal to 1 minus 2 sine squared alpha. So in this case, where we see alpha, we're just going to drop an 11 there, squared 11. And then the next one says 5.2 simplify. Yeah, this just looks too familiar, but anyways, let's see. I always say you can actually just let me actually finesse this question. So you see, remember, cos theta is the same as cos negative theta. So what I'm going to do is, you see here, you have to remember that what you see in here, right? You can see here cos x minus 180, right? Is the same as cos negative x minus 180. You see, because where you see a theta here, in our case here, it's just this whole thing. X minus 180, x minus 180. So in this situation, you can see from here, you can just carry on, right? If you multiply inside, then I have cos with negative x and positive 180. Now, the reason for doing this is so that you can write this swapped around. You can have 180 here minus x. Now, using your cast diagram, you can easily then now get an answer. C A S T. So 180 minus 180 degrees minus length in this quadrant where only sine is a positive. This is negative cos x. That's going to give you a good 5 marks. No, that's for this portion only. Ha ha ha. Then you have to deal with the square root of 2 in the sine x plus 45. The sine x plus 45, it looks like we can expand that using compound angles. So we're going to put here negative cos x plus square root of 2. And then in brackets, you have to be careful now. Sine with a plus is just sine x cos 45. And then your plus cos x sine 45. And then let's see here. Now the big idea with this kind of a situation is the fact that we're going to multiply inside now. It's like negative cos x. Multiplying inside, you're going to have cos 45. Oh yeah, let's not multiply inside yet. Let's change it to numbers first. Cos 45 is 1 over square root of 2, so we can write 1 over square root of 2 first here. Sine x. Here also the sine 45 is 1 over square root of 2. Now you can multiply inside in peace. You see, square root of 2, if you multiply inside, that's going to be like square root of 2 over square root of 2, which is a 1. Same here, if you multiply inside, you're going to have a 1 here. This is which is simplified to one trig expression, and here we are. You know that this is just going to be equal to sine x. And we keep moving forward. We love it. We love it. So with everything that has been said, right? If all this has somewhat been intriguing, then your best bet is the online courses. You see, you want to go to the link in the description and you want to make a purchase of the all access pass. All access pass. So as long as you can send me like a screenshot of this here, you can have the all access pass for 90 Rand for 30 days. You see, 30 days. So that's a 30 days access. See, 30 days access. But anyways, yeah, all you have to do is send me the screenshot of this. Just let me know. You can hit me up whichever way you can. Instagram, TikTok. If you go on the website and you scroll right down to the bottom, you will find other contact details. But anyway, let's do 5.3. 5.3 is obviously very interesting because we have sine p plus sine q is equal to 7 over 5. And then p plus q is equal to 90. Now, they say use calculate without using a calculator the value of sine 2p. Now, what we already know is that sine 2p is the same as 2 sine p cos p. Now, for you to have a sine and a cos next to each other, you would probably have done some kind of multiplication. So what we know is that they told us here that you have sine p plus q plus sine q, then you have equal to 7 over 5. What you already know is here you only deal with p's. You see, there's p here, there's p there. So what you can do for yourself is to write q here in terms of p. You see, the reason for doing that is, wait, there's supposed to be q here. Yep, the reason for doing that is, if you want to end up with things that are being multiplied together like this, you have to create a scenario like that, or you have to create a scenario that can potentially end up like that. Now, the one scenario that can be created is if you square both sides. But before squaring both sides, let's deal with this. So here we have sine p plus sine 90 minus p. And then we know that 90 minus is the quadrant where everything is a positive, C-A-S-T. But what we know is it has to change to a cos. So this is like sine p plus cos p. Sine p plus cos p equal to 7 over 5. Now the idea is if you're going to have these two pasted together, right, the sine p and the cos p, you're going to have to do some kind of multiplication. Now for you to add some kind of multiplication to this equation, you're just going to square both sides. See, because when you square this side, you now have like sine p times sine p squared, and sine p times the cos p. You're going to have two of those because it's going to happen twice. And then you're going to have cos p times cos p, which is like cos squared p. All this is good news on the far left. The reason it's good news is because sine p squared plus cos 2 squared is a 1. And then the 1 you see basically replaces those two terms. This is like a 2 sine p cos p, 2 sine p cos p, 2 sine p cos p, and then equal to 14 over 20, no, 45 over 25, no, 49 over 25, 49 over 25, right? And then obviously the 1 goes to the other side, 2 sine p cos p. This whole thing here minus 1. What does it give you in the calculator? Let's just check out this calculator here. Check it out, check it out, check it out. It is giving us 24 over 25. Yep, this question looks so familiar. Hey, but let's just carry on. Let's just carry on. Question number 6. Question number 6. Question number 6 says determine the general solution of cos x minus 30 is equal to sine 2x. Yeah, these questions, brother, they just look so familiar. Forget looking so familiar, brother. They just, they just took different papers and then you just threw them together, basically. But it's fine. So, question number 6 here. They said in the diagram, we should determine the general solution. How did I not give myself space for that question? Like, seriously. Hey. Yeah, no, it's weird. So let me just copy this question. The cos x minus 30 and then equal to 2 sine x. So this is the big idea. Let me cut this out. So the big idea is the following. Let me just do this. Let me do this. Do this. Bring it shorter. Move it there. Then make this go bigger. Move it over there. Okay, so I guess we're gonna have to do our question over here then. Right over here. Hey, we're not right over here. This was not writing. So if you're gonna get the general solution for a situation like this one thing you will always remember if you go through the trigonometry course on our website, where the link is in the description, you see courses.brightchangbands.co.za. The one thing that is mentioned about trigonometry questions, right, especially when you're getting the general solution, is that if you're gonna solve a question like this, you see there's cos here, there's sine there. Always change everything to cos. It's usually a better idea, But before you can do that, I mean, like the issue here is that you have this 2 here. The 2 seems like it's making our life a bit difficult, and it really is. But let's see, how many marks is our question here? It's out of wait, what? Yeah, it's out of no, come on. It's out of 6. Determine the general solution of this. So the 2 is definitely the problem. Because one way or the other, as long as this 2 is here, it's gonna be difficult to like drop it and all that. But I mean, like we could change another gear and keep in mind that we have compound angles over there, and the 30 is a special angle. So I mean, like seems like we could end up with something where we don't have 2 of these signs. Or let's just carry on. You see here, what I'm gonna do is cos 30 cos x. I mean cos x and then cos 30. If it's a minus here, you're gonna put a plus here. Sine. Now what you know is if you think of your right angle triangles for trigonometry, the one thing you'll always remember is that, or the one thing you can remember to help you remember the rest, the fact that sine 30 is a half. So you're gonna put 1 here, 2 there, and the other one's gonna be square root of 3. We know that this is just a 90-degree angle, this is just a 60. So what do we now know? This is like cos 30, right? Cos 30 is adjacent of hypotenuse. Square root of 3 over 2 cos x. And then sine 30 is like opposite of hypotenuse, so that's like a half sine x. And then this is equal to 2 sine x. So the fortunate thing is this, the ones with sine can go to the other side. You're gonna have 2 sine x minus a half, right? So it's gonna give you 3 over 2 sine x. This is like square root of 3 cos x. Now the thing is, since they're both over 2, you can just multiply by 2 here, like the fraction. Technically speaking, I mean, like, yeah. Let me not even write it like this. Let me just do this the way it is, square root of 3 over 2. But the big idea is, it looks as though we can actually end up with something that has a tan, So let's just do it. Let's just divide by, let's just see what happens if we want to divide both sides by a cos, you see. So let's do it. If you divide by cos x here, this cancels that. If you divide by cos x on this side, fortunately, you're going to have, this is going to be a tan, right? So it's 3 over 2 tan x. And this is square root of 3 over 2. And then obviously you can divide both sides by 3 over 2, divided by 3 over 2. And then you can just have here 3 square root of 3. This is what? 10x. There you go. 10x. So with this being said, we need to straighten, right? Now you can get your general solution nicely, because remember the general solution is where you end up doing your whole 10, 180, your whole 360, what stuff. So take everything to one side here, all the way here, and then what can we do? Red, and then here, go away. Red, there we go. Need to create some space here. So with this being said, you're gonna have your reference angle first. So from here, your reference angle is gonna be equal to shift 10, and then the number on the other side, this number, you always use it as a plus. And then depending on the sign of the number, you'll be able to choose which quadrants you want to work in. So with everything that we have just mentioned now, the reference angle is going to give us, what is the reference angle going to give us? The reference angle is going to give us 30. Is it giving us 30 though? Yeah, because wait, why wouldn't it give us 30? No, it doesn't make any sense. Let me grab my calculator quickly so that I can just quickly double check. Shift 10 Z. Oh no, it's not gonna give us a 30. The reference angle is not a 30, bro. Come on. How can it be a 30? Shift 10 square root of 3 over 3. Let's just see what that is. Shift 10 square root of 3 over 3. Oh yeah, 30. This is awkward as it gets. I think it's because it's the same as 1 over square root of 3. So our reference angle is a 30. The fortunate thing is we're working in the first, working where 10 is a positive. So 10 is a positive in the first quadrant, of which in the first quadrant we can say 180. We can say our value of x is equal to 180. What is this? Where is 10 a positive? It's the first quadrant, so you don't need to do anything. You can just say the reference angle plus k360. K is the element of integers. K is the element of integers. The second one, you can say the following. You can say there, what is this? X is equal to, well, 10 is also positive in the third quadrant, which is 180 plus. So it's going to be 180 degrees plus the 30 plus k360, whatever. 360, k is the element of integers. So here it's like 210 plus k360, k is the element of integers. K360, k is the element of integers. Okay, and that will be those will be your answers, and these answers, they're definitely okay. They'll get you all that you need. So let's move on. 6.2 says, in the diagram, the graphs of f of x and g of x are drawn in the interval negative 180, positive 180. Yeah, this looks way too familiar. Like it's almost irritating now. But it says, yeah, a and b are points on the axis, and then you have the 2 points, on the x-axis of f. This is the two graphs intersect at C and D. Two graphs intersect at C, D. Yeah, the intersect at C and D, the minimum and maximum turning points respectively of f. Then it says write down the coordinates of A. Coordinates of A, this point over there. See? Well, to get that point, how many marks? They're only asking for 1 mark, so you have to be strategic. The reason why you have to be strategic is the fact that is because you need to know what this means based on what the standard image would have looked like. The standard image would have been something like cos x. Now the idea is the graph of cos x would look something like here it would be at 1, right? And then it goes down and then somewhere at 90. So somewhere at 90 would be like maybe there. somewhere at 90 it goes down, and then by the time it reaches 180 it will be like, you know, somewhere down there, somewhere here. So the idea is, if you're seeing that the graph of f is the cost graph, this would have been a 90, right, where it cuts the x-axis. But the thing is, this is telling me that the graph was moved 30 degrees to the right. See, it's a horizontal shift. Horizontal shift 30 units right. 30 units right. So with that being said, right, this is what is up. Or this is what is up. Or this is what is up. Or. So with all this being said, right, what am I saying? The graph of f has been moved 30 degrees to the right. So if this is 90, this is just going to be 90 plus 30, which is going to give us, what am I saying equal to? Let's just say 90 plus 30, which is like what? 120. So therefore, the coordinate of A, x value is a positive 120, y value is obviously 0. And then let's cancel the coordinate of C. Well, C is the point of intersection, you know? They probably should offer us a bit of, only 2 marks. That's kind of crazy. It really is, because, I mean, like, yeah. But what you can actually do in this kind of a situation is you can use your general solution. When I say you can use a general solution, I mean, you can take a general solution and then you can check things from there. But this is a turning point of the graph, you see. That's why you need to be a bit creative. This is a turning point of the one graph, and it's also, so there's an x value and a y value. So what we can see is that the graph of f, the amplitude is still 1, which is okay. So here what you know is going downwards, this is just like 1 unit, 1 unit, 1 unit, 1 unit. And then the idea is, remember, this graph would have been turning somewhere at negative 180, but it was moved 30 to the right. So negative 180 moving at 30 to the right, you're going to get negative 150. Negative 150, the y values, this is like what? Still negative 1. Negative 1. And then, 6.2.2, it says, determine the values of x in the interval negative 180 to positive 180 for which both graphs are increasing. So we need a position where they are both increasing, meaning a position where they are both having y values going up. So what I can safely say is this, at this point here and at this point here, this is where the one graph is going from increasing to decreasing, right? Vice versa. Then for the other graph, it's doing that from here. It's starting to increase here until somewhere there. So we want a section where they are both increasing. And it looks like the section where they are both increasing at the same time is this one. There's this x value here, and there's this x value there. So what now? The x value here is straightforward. You see, it's between negative 90, negative 180 and 0. That's like negative 90. That's like negative 90, right? So let's put here negative 90. And then, well, we know that this turning point would have been at 0, but it has moved 30 to the right. So this is like positive 30. So between negative 90 and 30, you see. So here we can say, therefore, our x values need to be bigger than negative 90. They need to be smaller than 30. and then they're gonna give you 2 marks for that. You see, you can see these kinds of questions. I mean, like they need you to almost be like a veteran, you know. And the one way you can make sure that you're a veteran is to just sign up for the online courses. Like honestly, the trigonometry course. Now, the link to that is in the description. It then says here, well, technically we should still determine in the interval negative 180 to positive 184, which this is bigger than that. Well, what we can already see is that both here have, I don't know if you want to call it a, what do you call this now? So both of these, right, these are horizontal shifts to the left. Horizontal shift, 10 units, 10 units to the left or to the right? To the left. There we go, 10 units to the left. Now, they're asking us where the y values of f, you know, that's literally what they're asking, where the y values of f bigger than the y values of g. So the y values of f are bigger than the y values of g at specific points, but we'll consider the plus 10 just now. For now, we actually may not need to consider it. It will just make us think of a lot of things unnecessarily. So let me paste this thing here, and then we can begin with what we need to do to so this thing cooperates. Finally. So with what we have here, right, it is the kind of equation that obviously definitely needs you to like use your graph. Hey, why is this thing doing this now? Because if you don't use your graph, you won't be able to do anything actually. So let me crop this out, crop this, make this bigger, there we go. So remember the question here is where is f of x bigger than g of x, but then you want to then think of what would happen if they are both moved 10 units to the right, to the left. So f of x is this one here, and you can see f of x from this point to this point, it is above the graph of g, and we said that this is 30, this is negative 150. So because they are both moved 30 degrees to the left, it means that f of x, originally it's above from negative 150 to 30, but because they are both moved 30 to the left, you're gonna say your x values need to be bigger than 160. Well, why am I writing so bad? They need to be bigger than 160, but then those same x values need to be smaller. No, yeah, bigger than negative 160, and then they just need to be smaller than 30. And then you get your nice 2 marks there. So remember, every little bit technically counts. No, not 30. It's just supposed to be moved to the left. So it's like 20, bro. Come on now. Come on, bro. Can't be making a silly mistake like that. Yeah, because everything is moved to the left, you see. And then C. No, I mean not C, but the next question. The next one says determine the range. Now you determining the range of this question is all based on how high this can go. So you're gonna focus on 2 sine 3x. No, 2 sine x plus 13, right? So with that being said, what do we know? We want to find out what the range of this graph would be. So what you can do is to just visualize this sketch. It's a normal sine graph. However, this normal sine graph has been moved, what you may call. Yes, let me just do this. Right. So with this sine graph, it was moved 3 units upwards. So meaning instead of passing through the origin here, it's gonna be passing through somewhere here at 3. This is telling you the amplitude, meaning from 3 it goes 2 upwards, right, all the way to 5, and then it comes 2 down, back to the 3, and then it goes 2 down, back to technically 3, 2 down, that's like 1, then it goes back up. You see, so them asking the range, it's technically going to be from positive 5. That's the range of the portion that's like is what you call a fraction. I mean an exponent. On our exponent position, this can only be between 1 and 5. Now what we know is if if 2 to the power of this can only be between 1 and between 5, it means that technically we need to find out what is going to be the lowest value for this whole thing. The lowest value for this whole thing comes from where x is technically going to be a 1, because whatever this is going to give you is what's determining how high, whatever is going on is going to last. So let's see. What you're going to do here is for you to find out the lowest value, you're going to put 2 to the power of 1, that's a 2. To get the highest value, you're going to put 2 to the power of 35. That's fine. So here you can say that your range is between 2 and 32. And we see your graph does touch your graph, your points do go there. So you can just say therefore x is between what? It's between 2 and 34, 35. So x here is bigger, equal to 2, smaller, equal to 35. Wait, why am I saying 35? It's 32, bruh. Yo, 32, also 32, also 32. And then that'll be that for that specific question. Question number 7. In the diagram below, C, G, F, B. So C, G, F, B, and C, G, H, D are fixed walls that are rectangular in shape. And then they are rectangular in shape and vertical to the horizontal plane. Hence you see these 90-degree angles there. And then they said F, G, H. F, G, H. Wait, oh, no. Why am I reading like a 2-year-old, huh? Whichever way, they told us these are 2 walls, right? And they're vertical to this horizontal plane, which is FGH. So FGH is like the ground. And then they said here, still pose erected along FB, HD, to A. Wait a minute. And to E. Yeah, so you have steel poles going all the way to A up there. And then you have one going there to E. And then it says triangle ACE. Triangle ACE forms the roof of an entertainment center. Yeah, so ACE forms the roof of an entertainment center. Then it says here we have this dimension here is x. This dimension is x plus 2. And it says BAC is equal to theta. Where is BAC? There's theta over there. ACE is 2 theta over here. And ECD is 60. And then for 2 marks, it says we should calculate the length of AC in terms of x. So fortunately, calculating the length of AC in terms of x, that's not going to be a hassle. Mainly because it's a 2-mark question and we have, I don't know what we have. We have x over here, and we have theta over there. So you may, that's better. They say we can write it out in terms of x and theta. So we can just use normal trigonometry because this is like our opposite, right? And this is our angle, and this AC is going to be our hypotenuse, you see. So we know that opposite over hypotenuse, we can use sine theta. So sine theta is equal to opposite, which is x over hypotenuse, which is AC. Same. And then here, if you're going to make AC the subject of the formula, remember you can view this as something over 1. Let's put this over 1. And then you can just multiply by AC on both sides. Multiplied by AC, multiplied by AC. And then these will cancel out. You can have x here. Is AC dot sine theta. And then, excuse me, sorry, I don't know, I'm so sorry. I didn't mean to do that. So here you're going to divide by sine theta on both sides. Then you're going to have AC is equal to x over sine theta. There we go. Then here we should get CE in terms of x. Where is CE? CE is this length over there. Well, I'm going to do the same thing, but here it's adjacent over hypotenuse. You see, because we have 60 degrees there. And this is a right angle triangle. So we have adjacent over hypotenuse. So let's do it. Cos 60. We're going to say cos 60 is equal to adjacent, which is x plus 2 there, over hypotenuse, no, x plus 2, bro. X plus 2 there, over CE. So this is over CE. And then we know that this is over 1. You see, let's put this on top. Put this over 1. Now, what we need to do here is we just need to cross multiply. See, so cross multiplying, we're going to say 1 times the top part there, which is x plus 2, the bottom times that. Cos 60, we can get that in our calculator. So there's 60 here, 30 there. When I write this out, I always think of sine 30, because sine 30 is opposite, which is 1, hypotenuse 2. And then this just put square root of 3. So cos 60 is adjacent of hypotenuse, which is a half. And then, this is over, I forgot to put this over the CE. Weird. CE over here. And then obviously, if we want to make CE on its own, the first thing we can do here, fortunately, is a fraction. So we can cross multiply. 2 times the x plus 2 there, CE times the 1. And then we're going to multiply inside. 2 times x is 2x. 2 times 2 is a 4. This is like CE, right? And then that'll be that. You'll get your 2 marks. The next one says, show that the area of the roof ACE is given by this equation. So the area of the roof is not going to be difficult to get now, because you see, you can see the reason why they were asking us for AC and everything else, because AC here, you see it's x over sine theta. And then what we just worked out now is 2x plus 4. So there's 2x here plus 4. So you can see we can use the area rule here, because remember the area rule needs us to have an angle, and then that angle, right, we need to have 2 sides, one side on the one side of the angle, and then the other side on the other side of the angle. As long as we have this, we know we can use the area rule, because the area rule basically states something like the area is equal to half times A times B times sine C. The A and the B represent these two sides here, and the angle is in the middle. And it has to be like this, you see. It has to be an angle in the middle, and the sides, they are given. The opposite side, you don't necessarily need it. If you have it, it's still fine, but you don't need it. So let's put in our information. So in our case here, technically speaking, right, if you're going to write it as a formula, the area is going to be equal to a half. One of the sides is AC, the other side is CE, and then the angle in the middle is angle ACE. That's the angle in the middle, ACE. ACE. And if you put what we know now, you see this one was x over sine theta. And then we have 2x plus 4. And then we have sine 2 theta. You see. Now with what we have just put down here, let's just simplify. So if you see that you have a fraction and another fraction, and the other stuff is not a fraction, you might as well make it a fraction. You know, you help yourself. So let's make this a fraction. Let's make this a fraction. Put this over 1, put this over 1. So the top part and the bottom part, you're going to have 1 times x times this times this. So it's going to be x there multiplied by the 2x here plus the 4. And then sine 2 theta here. And then there's 2 here, sine theta. And then times 1 times 1. So obviously in this case, this is where you have to be a bit creative. You see, so because in this case you can see there's only a cos somewhere. So you can see this is the only thing that can help us. But let's multiply inside also. Maybe 2x there plus 4x. No, 2x squared plus 4x. Okay, really? Is anything squared? Okay. That's going to be awkward. Nope. We might as well not multiply inside. The reason we are not multiplying inside is because you see here there is x plus 2. And we can get x plus 2 somewhere here. Only if we take out, wait a minute, what's going on here? Yeah. Here you can take out 2. Because if the 2 goes out, right, you're going to have the 2 out next to the x here. Then you're going to have x plus 2 over here. And then here, you're going to have 2 sine theta and cos theta because of double angles. And then the bottom part, 2 sine theta. And then what we know is that the 2 cancels the 2, the sine theta cancels the sine theta. No, let's not remove. Let's not put it like that. Let's just say these 2 cancels this 2, this sine cancels this sine. And then you have 2x, x plus 2, and then your cos theta over there. You see. So the idea behind you getting these answers, you can see we're not doing anything crazy. You always just want to keep things normal. Because whatever you're going to write down to show whatever you need to show, it needs to be something that already exists. You don't have to like manufacture methods and stuff. For 4 marks, they said if theta is equal to 55, BC is equal to 12, calculate the length of AC. Yo, should have just sneezed. Yeah, but never mind. Anyway, so they've given us theta, right? Theta. And BC is 12. Where's BC? Maybe they're giving us X. Oh yeah, so they've given us X here as 12. And if they've given us X as 12, right, automatically remember, this is a 12 now. BC is 55, so this is a 55 now. And let's see here, this is 12. So let's do this 12. And then 12 plus 2. That's a 14. There you go. So if they're going to ask us to work out AE, fortunately we can use the cosine rule. The reason we can use the cosine rule is because the cosine rule is just like the area rule, as in you will need the sides on the, you'll need the angle in the middle and these two sides here to work out the opposite side over there. You'll need the cosine rule. Now the cosine rule basically states the following, you see. It looks something like this. It says a squared is equal to b squared plus c squared minus 2bc cos a. And then what we know is, all you need to remember about the cosine rule is that this here and this there, these go together. These will always be the angle over here and the opposite side. So as long as you can match this opposite angle and this opposite side, you'll be good to go, you see. So let's do that. So in our case, we're looking when the opposite side was AE, and then the other sides you have AC there, and you have CE. And then here, these two will be exactly what you have over here, and then cos the angle. The angle here is ACE, if I remember correctly. Yeah, ACE is our angle, you see, ACE. Now, if you put in values, AE is what we're looking for. AC, we worked it out to be 12 sine 55. And fortunately, all this we're just going to put into our calculator. 2x plus 4 was the value of EC, CE, and minus 2. So all this, the way I've written it out, right? Funny enough, this is exactly how we're going to put it in the calculator. You don't have to worry about anything else because it's a 4-mark question and you're going to get your marks for putting in the stuff in the calculator correctly, actually. So here, let's see what AE squared is going to be. So in the calculator, let me just see what this gives us in the calculator. So when you're going to be putting this in your calculator, you just need to be careful. When I say you just need to be careful, I mean you would have done all the heavy lifting. So if you see that all the heavy lifting is done, right, you just want to make sure that you put your stuff in your calculator carefully. So let me see here, putting all this in the calculator, we are getting here, let's see here, we're getting 1,000, 1,279. Let's just say let's see here, 0.4929. If you square it both sides here, you're gonna get 35.77. That's what AE is. Okay. So this is fine, nothing crazy, nothing major. We can move on to Euclidean geometry. Now the big idea is, remember, the way you are going to properly know how to answer these questions, you can only get it, well, I mean, as of this recording, the all access pass is on sale and it gives you access to everything. So if you're lucky, you can hop onto the website, you might see this exact same banner because it may go away anytime. Because tomorrow basically is, in this case, it's more of a metaphor to say this price tag can just disappear at any time. And the main YouTube channel has different playlists that basically take you through different topics in terms of their basics, you see. So if you need, for example, the basics of probability, you can always get them on this playlist, the basics of statistics, the basics of practically everything, Euclidean geometry, you can get them there. So once your basics are in check, you know that you can hop onto the course website, where you'll be able to go through different full courses of different topics. Like, for example, if you're working on trigonometry, right? Chapter 1, you have all these lessons here. Chapter 2, how to properly answer general solution questions. These are the ones where you have to do trig diagrams, working with trig graphs, and then lastly 2D and 3D triangles, just like what we were looking at now. This will help you. Like, okay, question number 8 says the following. In the diagram, what does question number 8 say? So we have a diagram here. Center is O. It says in the diagram, O is the center of the circle. Yes. And LOM. LOM is a diameter of the circle. Yes. So if that's a diameter of the circle, it means that this is a 90-degree angle, right? And what we also then know is these are equal. This is equal to that. Now, as long as this line is equal to this line, let me actually make it 3 of them so that don't get confused. So here it seems like there's a lot happening. Here you need to be fast to realize that there's a lot going on in this sketch, because if these lines are equal, right, and these lines are also equal, it means you have the midpoint theorem here. And it just means that this one is parallel to this one. Furthermore, it means that PM is double whatever NO is. That's what you need to remember from just reading the first statement, because as long as we have a diameter here, this means this is a radius, this is a radius. And if these are equal and these are also equal, it means there's a parallel, and it means PM is double ON. It's work that you need to know. And that kind of knowledge, you will get it from your online courses. You see, if you go to the online courses website, courses.bychangbrains.co.za, I mean, this package is currently on sale. If you're lucky, you might still find this, because this is more like a metaphor, to say that this will end at any time. But one of the courses is obviously the Euclidean geometry course. And all that we're learning now, you can learn it more in detail. You see, 3 chapters here, 4 actually. But anyways, it says here, is the diameter of the circle ON bisects the chord LP. So furthermore, it means that this is a 90-degree angle. And it makes sense, because if this is a 90-degree angle, then of course these are parallel, because they're corresponding angles. Also, you can see this small triangle here is similar to the big one. There's so much going on in this sketch, actually, like so much. Then it says T and S are points on the circle. There's T, where's T? T here, and S are points on the circle. Yeah, T and S are points on the circle on the other side of LM. So there's LM here. Then you have T and S on the other side. And then it says, yeah, T and S are points on the circle on the other side of LM with respect to P. Well, they're just describing the sketch, really, with their funny, weird words. But it says here, chords PM, there's chord here, PM and MS and ST are drawn. So as long as these are equal, right, we have to keep in mind that equal chords subtend equal angles. So if this is going to be 31, it means the other angle is also 31. You see, if this is going to be 31, it means the other angle there is going to be 31. So all that being said, right, we need to move on for 2 marks. It says determine with reasons the size of each of the following angles. The size of each of the following angles. So the first one is MOS. So getting MOS is not so difficult, because yeah, depending on how well you understand this work, you can already see that this is an angle at the center of a circle. So you always check which chord is subtending that angle, and it's subtended by chord MS. So an angle at the center is double the angle at the circumference, if they're subtended by the same chord. So for 2 marks here, we're going to say this is equal to double T. The reason for that is angle at center of circle. Angle at the center of a circle. So here, therefore, MOS is equal to double 31, just equal to 62. So since we're dealing with Euclidean, we can just remember Dr. Cape Town, DRCPT. Dr. Cape Town, if you're not familiar with Dr. Cape Town, it's basically one of the methods that you can use to always remember how to answer Euclidean geometry questions. So if you go to our Euclidean geometry playlist on the main channel, you'll notice that there's a tutorial down here. Is it one? No, it's not in this playlist. It's in the other Euclidean geometry playlist, because there are 2 Euclidean geometry playlists. The other one is this one, Euclidean geometry. If you scroll down, you'll have a tutorial that's labeled strategy to approach riders. You see, it's just short. It will show you everything you need to know. This means diameter, radius, cyclic chord, parallel lines, tangents. It's a way to help you remember like the different theorems and all that. So the next question is asking for L. L is over there. We said it's equal to T because they are equal chords subtending equal angles. So L here is equal to T. The reason is equal angles subtend equal angles, no, equal, whoa, I wrote angle and then angle. Yeah, equal angles subtend equal chords. You see, that's the reason. So here, therefore, T is also equal to 31. I mean, L is also equal to 31. Come on, bro. Come on now. L equal to 31. Now, with 8.1.2, that's a 4-mark question. It says, prove that ON is half of MS. You see, that's not going to be difficult now. Because remember, first we have to tell them that OL is equal to OM, as we said. We have to tell them that they're equal because they are radii. LO is equal to OM because they are radii. That's the first thing. And then once we've told them that those are radii, those are equal, we need to tell them that these are also equal so that we can tell them that these are parallel. So we're going to say N1 is equal to 90 degrees. We're going to give our reason there. N1 is equal to 90 degrees. The reason is line from center bisects chord. Because all we're mentioning is always all the things we mentioned in the beginning. You see, we're mentioning them, we're telling them that we know these are equal. Perfect. And then this is 90, right? We need to tell them that this is also 90, the P there, so that we can tell them that those lines are parallel. So P is also equal to 90. The reason is angle in semicircle. Angle in semicircle. So with that being said, now that you've shown that these are equal and that these are both equal to 90, you can tell them that ON is parallel to PM. Therefore, ON is parallel to PM. The reason is corresponding angles. So your job would be to just show that these are equal, and these are parallel. Lastly, you can tell them that NP is equal to LN. That's a given. NP equal to LN, that's a given. Now, the good news is as long as all those things have been stated, these are equal, these are parallel, you can state that therefore ON is half of PM. And your reason will be midpoint theorem. Therefore ON is equal to half of PM. The reason is midpoint theorem. Because you have shown that if a line inside a triangle bisects both sides of the triangle, it means that the line inside here is half the line there. That's your midpoint theorem. And that is something that is stated within one of your Euclidean geometry tutorials on our main channel. You see, if you go to the Euclidean geometry grade 12 playlist, you'll see here it states midpoint theorem. That's how you're going to learn what we have just mentioned now. So let's see. 8.2 says, in triangle ABC, all these sketches, they just look so familiar, like goodness. I feel like all these questions were taken from, I don't know, honestly speaking, it looks like they were taken from a bunch of things that I've gone through at some point in time, somewhere, somehow. Yeah, it's so interesting. Oh well. It says here, in triangle ABC, ABC, K is a point on AB. K is a point on AB, yes, such that K, the ratio between AK and KB is 3 to 2. So remember the ratio between AK, so it's 3 to 2, right? So I can say 3x here, 2x there. And M are points on AC. Huh? Yeah, M is a point on AC such that these are parallel. BM intersects KL. BM intersects KL at L. And then it says the ratio between M. Wait. Yeah, oh snap. There's something chopped off here. Snap. Oh no. It's here. Wait, why does it seem like something is chopped off over here? Oh wait, it says N and M. Oh yeah. N and M are points on AC such that these are parallel. And then it says that BM intersects KC at L. And then it says here AM, the ratio between AM and MC is 10 to 23. So where is AM? AM is here. This whole thing here. Let's just say 10Y. MC is 23. 23Y. So determine with reasons the ratio of AN and AM. So that one is not going to be difficult because in a situation like this one, you're just going to use this portion of your sketch over there. You see, because this portion of your sketch here, you have the ratio on this side 3 to 2, right? And here you have the whole line here, it's 10y. So you basically want to share 10y using the ratio 3 to 2. That's how you're going to get AN over AM. So to do that, right, you have to remember your ratio is 3 to 2. If you're going to share 10y using the ratio 3 to 2, what you do is you plus them up, you get a 5. And then you say 3 over 5 times 10y. And then you say 2 over 5 times 10y. You can actually just say 10, but this just makes life a bit more, easier to work with. So what you're going to get here is 10 times 3 is like 30. Over 5 is going to give you 6. 10 times 2 is 20. Over 5 is going to give you 4. Like that. So 6y, 4y. And then you need to carry on from here. So what you now know is that this is just giving you 6y, just giving you 4y. So that now you can say, firstly, AN over AM, right? AN over AM is the same as AK over AB. You see, the reason for that is just proportionality theorem. Now, with that being said, fortunately, you can then say, therefore, AK over AB is equal to, well, you don't even, maybe not, let's not say therefore, let's just write it out. AK over AB, right, is going to be, no. Do we need AK over AB? No, we don't even need, what am I doing? We don't need anything like this. Well, do we? Wait, this is so weird. We don't even need to have done all this that we've just done here. Yeah, all this that we've just done was actually overkill because we can just use AK over AB, you know, because AK is 3x, and then AB would have been 3 plus the 2, which is like 5x. And then here you can see this cancels that, which is just equal to 3 over 5. You see, therefore, AN over AM to the 3 over 5. Yeah, I guess all this was just extra. We might as well even remove it, but we can leave it for the next one, you know? Leave it for the next question. Having to have done all this, we could have still ended up with 3 over 5 if we, let's say, said AN over AM, right, is equal to the 6 over the 10. You know, that's another way you could have done the same thing, you see. So let me actually even do it like that, because I'm trying to show you that I guess there are two ways to have just done this, you see. So without having to have done, with having to have written all we have written here, we can easily then say here, therefore AN over AM, right, is just going to be 6y over 10y, based on what you would have just written out here. And then you can just send one, y cancels y. 6 over 10 is just 3 over 5, you see. You still end up with the same thing. So I guess what we did here was just overkill, but we've given ourselves more information for the next question. It says we need to get the ratio CL over LK. CL over LK. Well, I guess our life is a bit easier because CL over LK is the same as CM over MN, you see. This is equal to, so CL over LK is equal to CM over MN. CM over MN. And then this here is going to be equal to 23y. 23y. MN is going to be 4y. 4y. Wait, these are equal because of the proportionality theorem. We have to give a reason here. Prop theorem. And then here, so these are, this is equal to this. So what we know is this is just going to be equal to 23y over 4y. And then, let's see here. We're going to put y over y. Then this is like 23 over 4. This is what CL over LK is. And then you keep it moving, you know, you keep it moving. Question number 9. It says the following. In the diagram, right, tangents are drawn from point M outside the circle to touch the circle at B. So if this is a tangent, then it says that the straight line from B passes through the center and of the circle. Wait, the straight line from B passes through the center of the circle. Yes. And then it says here MN produced in A. Wait, what? Why does it seem so weird reading this statement? But they just want to describe the sketch. You have A, you have B over here. It goes all the way to A. And then you have MN here. It goes also to A. And then it says here MN. There's MN here. It goes all the way to K, such that you have these lines that are equal to each other. They said BM, right? BM is equal to MK. And then it says here BK and BM, BK and BN, they are drawn over there. Then they say this is angle X. Fine. So that being said, let's see what we can do. If this is X, it means that this is also equal to X, because base angles of an isosceles triangle. And let's see what the other thing is. You see Dr. Kaplan, DRCPT. DRCPT. Diameters. Well, here we don't have any angle subtended by the diameter. But okay. Well, we have the 10 chord theorem though. No, we don't. because there's just a tangent here. What we do have is a 90-degree angle here, because a tangent is perpendicular to the radius. So that's just us trying to analyze just a little bit before we dive into this. So for a whole 6 marks, they say determine with reasons the size of n1 in terms of x. So if you're going to determine n1 in terms of x, the best you can do is to try and make sure that you get as much of your sketch written out in terms of x also. Firstly, like as we said, if you see that this is x stated, because you're going to need it, most probably. And then also here, this can be written in terms of x. And the reason I'm mentioning that is because you see, if you look at where n1 is, and if you look at where b2 is and all that, whichever way, in this triangle here, in this triangle, this is the triangle where we find n1, right? So I'm also thinking of things like, you know, exterior angle for triangle and all that shandies, you see, because if you see here, this here means this is an exterior angle, it's going to be equal to that plus that. And we have two tangents from the same point. So yeah, because look, in the diagram, tangents are drawn from M. Yes, to touch the circle at B and N. Yes. So it means that these two lines here are also equal. You see, if they told us that these are equal, right? And we know that this tangent is going to this circle, this tangent is going to this part of the circle. Tangents from the same point are equal. So automatically we know that whatever this side is, it's equal to that side. Whatever this angle is, it's equal to whatever this angle is. So, wow, I feel like you just cracked the question here. Because look, there's M1 over here, there's N1 here, there's B2 there. These are equal to each other, you know, because of these lines. So M1 is equal to these two put together. So if we get M1, we'll easily be able to get N, because N is just going to be M1 divided by 2, since these are equal to each other. But all this, we were just saying it, right? You want to just write it out now, bit by bit. So how we analyzed this, we just made use of all the information we have. You see, they told us we have tangents. So we thought of theorems that deal with tangents. And then we also thought of this acronym, TPEX. So this acronym basically reminds you of angles on a straight line because of the T here. And then the I is just there. P here reminds you of exterior angle of a triangle is equal to the sum of the opposite ones. And then X is for vertical opposites. The E is just there so that it spells out TPEX, you know. So let's start by mentioning that we know that this is equal to X, because it's going to help us write M1. B1 is also equal to X. The reason is base angles of an isosceles triangle. M1 is then going to be equal to 180 degrees minus 2x. You see, because there's x there, there's x there. The reason here, interior angles of a triangle. And then we're going to tell them that these are equal because they're tangents from the same point. MB is equal to MN, tangents from the same point. So these tangents from the same point, they're equal, fine. Then now we can say, therefore, N1 is equal to B2. Therefore, N1 is equal to B2. The reason is base angles of an isosceles triangle. Base angles of an isosceles triangle. Another reason you could have also just said angles opposite equal sides. That's another way to state it. Angles opposite equal sides. It's the same idea. You could have also written here angles opposite equal sides, you know. I'm just writing them like that, writing both of those ways so that you can see both are valid. So because you have now stated that these are equal to each other, we are home free, because now we can say M1 is equal to these two put together, right? M1 is equal to N1 plus B2. The reason is exterior angle of a triangle. And remember, the big idea here is these are equal to each other, you see. So here we can say, therefore, M1 is equal to N1 plus N1, because, I mean, like, this can be written as N1 since they're equal to each other. This, we know it's 180 degrees minus 2x. N1 plus N1 is 2N1. Divide both sides by N1 and by 2. We're going to have here 90 minus x. That's what N1 is equal to in terms of x. So it's a 6-mark question because you can see, yeah, it's a lot of writing statement. But I feel like maybe if you wrote on a bit less, you still get your 6 marks as long as, you know, the process is the same. But there's no need to write less when you can see all this. You might as well just write all of it. So 9.2 says, prove that BA is a tangent to the circle passing through KBN. Where's BA? BA is this one. They say you should prove that it is a tangent passes through. You should prove that it is a tangent passing through B. You should prove that it is a tangent to the circle passing through B, K, N. Okay, so the one way you're gonna do that is you just need to show that this angle here is equal to this angle there. You see, because an angle, this angle here has to be equal to that angle if you're going to have a circle passing through these points here, the 10-chord theorem. So we just have to prove that B3 is equal to X. Now to do that, what's the mark allocation? It's a 5-mark question. Yeah, so it's not going to be just straightforward. We have to think strategically. Fortunately, we know that this whole thing here is equal to 90, and we know what this small piece is. Remember, this small piece here, we've proved it to be 90 minus x. So I think this is our gateway to show that this is equal to x. Let's firstly tell them that MBA is a 90-degree angle. Let's do it. MBA is equal to 90 degrees. The reason for that is tangent perpendicular radius. Tangent perpendicular radius. And then now we know that this is, yeah, we say this is equal to 90. Fine. Now because this is 90, we can say B2 plus, we know that B2 plus what? Let's actually write it like B2 plus B3 actually, because it's going to be easier for us to write it algebraically. B2 plus B3 is what's equal to 90. It's the same as this big angle here, but likely we can just write it separate for calculation purposes. So because we've shown that these are combined, giving us a 90, the next thing is we can tell them that we know that B2 is equal to N1. The reason is that's already been proven, but you can even just state it again, you know, like angles opposite equal sides. It's up to you. So here you can say therefore B2 is also equal to 90 minus x, because you see this is 90 minus x and the other side is also equal to 90 minus x. So with all that being said, we can put it in our statement here. Therefore, we have B2 here, right, which is 90 minus x. If you add B3, is equal to 90. And then this is just what? 90 goes to the other side, it's like 90 minus 90. X goes to the other side, it's going to be x. 90 minus 90, that goes away. Therefore, B3 is equal to x. There we go. So now that you've shown that B3 is equal to x, you're good to go, you see, because now you can say B3 is equal to K, more of a conclusion. Therefore, B3 is equal to k. That's been proven now. So now you can say, therefore, BA is a tangent to the circle passing through KBN. So BA is a tangent to the circle passing through KBN. The reason for that is converse of tan-chord theorem. Converse of tan-chord theorem. That's the reason, because the tan-chord theorem would need to stand if there's a circle passing through those points there. And that's that for this question number 9. Question number 10, the most boring proof in Euclidean geometry history. Yeah, this theorem is so boring. I don't even want to lie. It's boring. It's annoying. Yeah, it just sucks. So it says in the diagram, A, B, C, and D, E, F are drawn such that A is equal to G, B is equal to E, C is equal to F. Use the diagram in the answer book to prove the theorem, which states that if two triangles are equiangular, then the corresponding sides are in proportion. That is AB over DE is equal to AC over DF. So, fine. With this kind of a theorem, right, you firstly, one or the other, need to start with the construction. So, construct. You're going to construct, let's say A, B, C, D, E, D, E, E, no, D, E, F. So let's say GH. You're going to need to construct GH. So this is a very annoying theorem, but just bear with me. So you have to construct GH parallel to BC, and construct GH parallel to BC such that GH is equal to EF. You see, so your construction, you have drawn this line here, but then you have made sure that it is equal to EF. You see, and then here, yeah, so construct GH parallel to BC such that GH is equal to EF and AG equal to DE, and lastly AH equal to DF. That's literally what your construction is. So your construction is in such a way that you're almost like taking this picture, you're dropping it in there. So all this being done, right? Let me use a different color. So all this being done, 1, 2, 3, 1, 2, 3. All this being done, you need to be careful now. The reason why you need to be careful is because of the following. You need to be careful. So with this being done, now you can just work with this sketch, because the way this sketch is laid out, right, you can basically state that since what you may call this is equal to that, this is equal to that, this is equal to that, what you already know is, based on your construction, as long as these are parallel, right, it means that this is also equal to x, and it means that this is also going to be equal to this dot here. But then without even going that far, right, this proof needs you to know these specific steps without worrying too much about finding your own ways of writing out this theorem, you see. So here we said we constructed, let's just recap, we constructed GH and we made sure that all these other lines are equal to each other. And then the one thing we want to do is we want to state that all the angles inside our sketch here is, apart from just the angles being equal to all the angles in there, what we want to do is, based on our construction, we basically just want to state that these two are congruent. So the first thing we can do is we can just state that GH is equal to EF, GH equal to EF, and then the reason is just construction. I know, sounds dumb. And then, so since these two are equal to each other, that's a side. So our goal is to prove that this triangle is exactly identical to that one. That's the first thing we want to do. So the way we do that is you need to show that at least three things of this triangle is equal to three things of this triangle without necessarily stating that it's three angles and three angles. So far we have found a side equal, and then we're going to say A is equal to D, that's a given. A equal to D, that's a given. And then here you can state that, wait, so we have an angle and a side, so we can state another side. So us stating another side, we can just use what? AG and DE. AG is equal to DE, the reason is construction. You see. So what you've just done right now is that therefore triangle DEF, triangle DEF is congruent to AGH. AGH. The reason is side, angle, side. You found a side equal, found an angle, found another side. And then before you carry on, now that you've shown that these two are congruent, now you can whatever you want, basically. Not you can do whatever you want, but now that you've shown that these are congruent, right? You can basically what you may call state the following. Well, the other thing is, you see here our construction, we do not necessarily need to make these parallel. Let's just get on. We made it parallel based on our construction. So with everything that we have just stated now, right, our sketch is just ripe for the proportionality theorem. So with our proportionality theorem, we're going to state that AG over, that's what we're trying to state here, AB, we're trying to show that AB over DE is equal to AC over DF. So we're going to work with the big triangle and the small one in there. So, but before we do that though, one other thing is your construction, right? You do not necessarily need to forge these lines being parallel. What I mean is, if you just say construct GH equal to this equal to that, and this equal to that, you will be good enough. You'll be fine. If you had just constructed, let's say here, construct this, right, and you don't do that, this is good enough. And then once you've constructed all these, right, making sure they're all equal to each other, you are still able to write out all that we have just written out over here. And then once we have written out all that we have just written out here, we can now then state that these lines here are going to be parallel to each other. The reason why we're going to be able to state that they are parallel to each other is by firstly stating that all the angles in here, we're firstly going to need to state that the angle in the angle over here, AGH, is going to be equal to the B over there. AHG is going to be equal to the C over there. So with that being said, let us carry on. So carrying on, we need to keep in mind the following. We need to keep in mind that as long as this triangle is identical to this one, remember it means that AGH is equal to E. So let's state that AGE is equal to the angle ADF there, DEF, which is both equal to X. You see, the reason is it's corresponding angles of our two angles that are congruent. See, but we can just say proven here, because if you've proven that your triangles are congruent, it means they're identical. So now that you've shown that this is equal to X, you can easily then state that GH is parallel to BC. GH is parallel to BC. The reason is corresponding angles are equal. Corresponding angles are equal, so lines are parallel. That's just me adding some extra there. Anyways, now that you've shown that you have parallel lines and all that shandies, now you can easily state the proportionality theorem. So here now you can state that AB, which is the big line there, let's see, you're going to state that AB over AG is equal to AC over AH. You see, let's do it. AB over AG, AB over A, is it G? No, yeah, AB over AG is equal to AC over AH. AC over AH. And then, with all that being said, the reason here is just proportionality theorem. And then from here, you need to do the following. When I say you need to do the following, I mean, as long as you've proven that this is equal because of the proportionality theorem, you can then say, therefore, wait, did I say AG? Yeah. Now, here what we know is, with this being said, right, you can then state that we know that AG is equal to AB. And we know that, let me see here, what are we trying to do? We have AB up here, we have AC up here. The only thing is, you see down here we have DE, down here we have DF. So in our expression here, we have the AB here, we have the AC over there. So we just need to show that this AG is equal to DE, this AH is equal to our DF, because that is something that we have already proven. So with this statement being said, right, remember, based on what we mentioned up here, you see, AG is equal to DE, AH is equal to DF. Here we can then say, therefore, AB over DE is equal to AC over DF. You see, here you can just show that AG is equal to DE and AH is equal to DF. You can even add their construction. So that's why I say this proof is really one of the really boring ones. I won't lie, it just is. But it's kind of free marks also, because I mean, like, you just show that you just make a construction in the triangle, and then you make sure that you tell them that, okay, this line is equal to this one, this is equal to this, this is equal to this. After stating that, you can then show that the triangles are congruent. After showing that the triangles are congruent, you can then show that you have an angle here equal to that one, then therefore you have parallel lines. Once you have parallel lines, you have the proportionality theorem now, and then you can state what you've just stated here. This over this, I mean, this over that is equal to that over that. Then you write it out. These are equal to these two, and then you finish. 10.2 is a Euclidean geometry question also. It says, in the diagram, O is the center of the circle, and CG is a tangent to the circle at G. So you have CG here, right? CG over here. Over there. Now this tangent, it's CG CG is a tangent to the circle at G. Then he says the straight line from C passes through O, going to A. Then he says here, it passes through A and B. Then he says your diameter DOE, you have diameter DOE is a diameter, fine. So these lines are equal, and then these lines are equal, fine. Yeah, DOE is perpendicular to CA, and then it says GE and CA intersect at F. CA and GE intersect at F. Yeah, this paper was just a lot of recycled questions, Forget a lot of, it's all of them. These are all recycled questions from other past papers. Then it says here DG, BG, and AG are drawn. So you have DG here, BG here, AG. They're just lines there. For 3 marks, they want us to prove that D, G, F, O is a cyclic quadrilateral. For 3 marks only. The one thing that stands out is this. The fact that this is a 90-degree angle, because this is an angle inside a semicircle. Remember, we have a diameter here. And for a cyclic quad, as long as you can show that opposite angles are equal, as long as you can show that opposite angles add up to 180, you're fine. It just so happens that these are equal to each other. And they're both equal to 90. So if they're both equal to 90, fine. 90 plus 90 gives you 180. So they can still help us prove the theorem. So let's do it. We're going to state that DGE is equal to 90. The reason for saying that these are equal to, the reason for saying that GGE is equal to 90 is angle in semicircle, angle in semicircle. Now that you've stated that this is equal to 90, what you need to do is, this is also equal to 90, that's a given. DOF is equal to 90. DOF is equal to 90, that's a given. So here you can say, therefore, DGF plus DOF is equal to 90 plus 90, which is equal to 180. And then here you can say, therefore, DGFO is a cyclic quad. The next question needs you to prove that GC is equal to CF. Where is GC? GC equal to CF. GC equal to CF. You need to prove that these are equal. So proving that those are equal, you can, there are different ways to do it, but if you can show that this angle is equal to this angle, you will be home free. But let's check our mark allocation. It's a 5-mark question. Yeah, it's a 5-mark question. So yeah, it's not playing games, this question. It's not playing games at all. So the things that I'm thinking of is things like, as long as you've been asked to prove something, right, don't take it for granted. Because normally whatever you're asked to prove is what may help you to answer follow-up questions. So the reason I'm stating what I have stated now is because, I mean, one or the other, our cyclic quadrilateral here, it means that this F1, right, is equal to the angle D there. Now, whether that's going to be useful or not, yeah, that's the thing, man. We just don't know. But yeah, with this kind of a question, I mean, like, we maybe do want to be a bit strategic, and we don't maybe want to, what you may call, we don't want to overthink it. The reason why we don't want to overthink it is because just try and use what you would have just worked out to help you. Because normally what you'd have just used to, normally what you'd have just worked out, right, it usually is very helpful. So let me show you what I mean. Here we know that F1 is equal to D because exterior angle of a cyclic quadrilateral. Let's write that down. F1 is equal to D, exterior angle of cyclic quad. So whatever you normally prove is a good place to start. So we now know that this is equal to D also. Fortunately, we have the 10 chord theorem here. You see, the 10 chord theorem, remember the angle between a tangent and a chord. You see, there's a chord here, this angle here. This is the tangent, this is the chord. Now, it basically, you're seeing that G1 plus G2, which is the angle over there, right? It's equal to D. So you see FGC is equal to D. FGC is equal to D. The reason is 10 chord theorem. Chord theorem. Now, obviously, because this is equal to this, right, it means that these are also equal to each other. You see, therefore, we can just say FGC, therefore FGC, FGC is also equal to F1. The reason here is you can just say D, angle D is equal to, it's more like a conclusion actually, you know, because I mean, like, if they are both equal to D, it means they're equal to each other, you know. So with that being stated, we can now say therefore CG is equal to CF because those are lines opposite equal sides. So CG is equal to CF. CG is equal to CF. The reason is lines opposite equal angles. And that will give you your 5 marks. The next one says 10.2.2. If it is further given that OC is equal to 11 units, DE is equal to 14 units, calculate the length of BC for 3 marks. So OC and DE are given. OC is the whole length here. And then what's the other one? DE. DE is the diameter. DE, they gave it to us. Well, this is a diameter, right? If DE is equal to 14, it means this is 7 and this is 7. OC is equal to 11. OC is equal to 11. DE equal to 14. That all being said, they're asking for BC. BC is this small piece over here. Well, the one thing you may be asking yourself is why did they give us the BE? I mean, the DE rather. So if this is 7 and this is 7, it means that, let me just make one line here. If this is a 7, this is the radius, right? Radius. Remember, OB is also going to be equal to 7 because it is also the radius of the circle. So I guess we could start there. You know, let's just tell them that, you know, OA, I mean, we can tell them that OE is going to be half of 14, you know, because, well, no, we can tell them that DO is equal to OE. And then we say radii, so that we can state that they are both equal to 7, you see. DE is equal to 14. I mean, it's got to, what am I saying here? DO hypo. DO is equal to OE red eye. Therefore, DO is equal to half of 14 equal to 7. Here you can say, wait, let's just state that all three are equal. DO, OE, and OB, because they are red eye. And then we can say that this is equal to half of 14, fine. We just wanted to do this, so we can also say that this is equal to 7. So they are all the radius. We have shown that one of the radius is equal to 7, so it means OB is also equal to 7. The reason we're stating that OB is equal to 7 is because OB is part of the line that we are dealing with. You see, because I mean, like, the whole thing here is 11, which is, yeah, 11 minus the 7 will give us the BC, because it's all on the same line anyways. You see, so here we can say, therefore, BC is going to be equal to the whole line, which is OC, which they've given to us as 11, OC minus the OB that we've just worked out is going to be 11 minus 7. It's going to give you 4 units. You see, easy peasy. The last one says we should work out the length of CG. Where's CG? There's CG, which is one of these lines here. So if you're going to work out that length, I mean, fortunately here we have a 4, right? So you may be thinking to yourself, okay, I mean, that's probably going to help us to a certain extent. And I mean, like, one or the other, it should, right? One or the other, it should. I feel like I wrote down too much. No, what's going on? 10.2.2a. Where 10.2.2b, right? Yeah, we need to calculate the length of CG. So you calculating the length of CG, right? You have to be a bit careful with this one. Let's see. The reason why we're saying we have to be a bit careful is because if you look at the, what you may call, if you look at where CG is in a very interesting spot. When I say it's in a very interesting spot, yeah, it just is, you know. It's just in a very interesting spot. The reason why I say it's in an interesting spot is because in this triangle in particular, right, we don't exactly have a lot going on in terms of like lines and everything. The only thing that we can use to help us is probably like a triangle that that also has lines and sides given and everything. So with this kind of a question, it's really the kind of a question where you have to think outside the box. Because if you look at the dimensions that we have in our sketch, right, we have this one, which is 11, and we have this one, which is 7. And then we have this tiny one, which is a 4. So we have the 4, the 7, the 7. The whole thing is 11, the whole thing is 7. So meaning we have this whole line here. The whole line here is 18, right? And this whole line here, the only way it may be useful is if we think of which triangle is inside. Which triangle is this line inside? And that's the triangle AGC. So we could be thinking of triangle AGC because of the whole line here that has a dimension. The other thing is, if we think of this small triangle here where we need to find the line GC, if we're thinking of this isosceles triangle, it's useless. But then if we're thinking of a triangle that has GC in it, there's G here, there's C here. A triangle that has GC that may at least maybe look like this is triangle GCB. See, like that. GC and B here. So with everything being said, the one thing we can already see is one way or the other, because this is Euclidean geometry, you may want to prove that these two triangles are similar first. And then once you've proven that they're similar, you can then do what you need to do to get the line GC. So fortunately, these are, you have a common angle over here. You see, you have a common angle over there. So this is a common angle. And I mean, one way or the other, I mean, just because of the way this looks, you can almost see that these are the ones that are going to be equal. And then lastly, these are the ones that are going to be equal. So you proving similarity between these two triangles, just use two pairs of angles that are the easiest to prove. So the ones that I can already see is, you see there's the common angle over here, and then there is also the pink ones because of the 10 chord theorem. Let me show you. The angle here, right? The angle here in this triangle is equal to that one because of the 10 chord theorem. And then the angle here, which is the green one, is equal to the angle there also, which is the green one, because it's a common angle. So those are the things we're going to use to prove that we are dealing with triangles that are similar to each other. So let's start with stating that we're going to label this triangle GCA, GCA, that's triangle GCA. And then this one, we're going to label it BCG, BCG, BCG. Okay, let us do it. So what do we now need to do? So here we can say, yeah, in triangle, scrolling up and down is just not gonna do like, let's just do this, copy, and then I'll just paste it down here. So this is what we're dealing with, right? And this, I labeled it A. So the first thing is we're going to state that we're going to say in triangle BCG and triangle GCA. We're trying to tell them which triangles we're working in. So now the first thing we're going to say is angle C is equal to angle C, common angle. And then we're going to tell them that the BGC is equal to GAC. Let's do it. So BGC, this BGC here is equal to GAC. GAC. The reason is 10 chord theorem. 10 chord theorem. And then anytime you have shown that at least two pairs of angles are equal, the third pair is automatically equal because of interior angles of a triangle. So here you can say, therefore, the pink one, the yellow ones, right? AGC, AGC is equal to GBC, GBC. The reason is interior angles of a triangle. Now, with all that being done, you can now say, therefore, the two triangles are similar. Therefore, triangle BCG is similar to triangle GCA. The reason for all that is just angle, angle, angle. You have shown that three pairs of angles are equal. Now that you've proven that these triangles are similar, now you can write out expressions, right, that can eventually help you to write out the length of GA. Because now you can say BG over GA is equal to CG over, wait, what am I doing here? I wrote it in, dude, come on, bro, focus. BG over GA. BG over GA is equal to, why am I doing it funny? Just do the McDonald's face, bruh. Come on. Because when I studied like that, it doesn't work out. So you have to say BC over GC. BC over GC is equal to CG over CA. CG over CA, which is also equal to BG over GA. BG over GA. There we go. The reason here, you're just going to say proportionality theorem. Can't believe I ran out of space. I'm writing way too big. So all this being said, right, you need to now have our conclusion, because with all this being said, what's useful to us is actually only something that has GA in it, which is going to be this technically. And then we also need one of these that at least has dimensions that we can use, because if we don't have dimensions and numbers and lengths and all that, all this is practically a bit useless to us. So fortunately here we have BG. Wait, what do we have here? Nah. What are we being asked again? CG is what we're looking for. So since we're looking for CG, right, we're going to obviously need to make use of this one here. Let's look at the triangles that we have, right? So in our triangles, we mentioned that we have lengths given for AC, and we have BC, which is a 4. So AC and BC have lengths. At least we have AC here. BC also has a dimension, so we might as well use that one as well. So these are the two we're going to use. So knowing that these are the two we're going to use, we're going to say, therefore, BC over GC is equal to CG over CA. It doesn't matter if these are swapped around. These are still the same. So from here, you can cross multiply. This times this is going to give you GC squared. BC times that is going to be BC times that. This is just 4. This is just 18. And then this is like what? What is 4 times 18? 72. Square root both sides. Therefore, GC is equal to square root of 72. That's like 8.49. 8.49. 8.49. 49. And that is the way we like it. So now moving on to the last one. What we have, yeah, this is the last one. It's a former question asking us to work out the angle E. E is, where is E? E is this spot over here, down here. It's quite an interesting spot. But the strange thing is we have dimensions. So as long as you have dimensions, I mean, you can do a lot. You really can do a lot as long as you have dimensions given. So if you're going to work out the angle E, right? Yeah, it's going to be, it's not just going to come, and knock in the face. But fortunately, we have a right angled triangle. And as long as we have a right angled triangle, somewhere, we usually have a better time working out what we need to work out. You see, so let's see what we have here. We have all, here we have 4, right? Fine. And then what do we also have? We just got this G. Yeah, so GC, we got it as the square root of 72. Let's just write the square root of 72. So the whole thing here is also square root of 72. So if we have this whole thing here, right, you may be thinking to yourself, okay, E is inside this big right angle triangle, but that big one is not useful. The only right angle that's going to be useful here is this smaller one. because it at least has the 7 there. You see, it's a right angle triangle. So what we know is if we can just get OF, we're good, because we can just now say opposite over adjacent and use 10 to get E. So let's get OF. OF is going to be the whole length here, which is 11 minus square root of 72. You see, so let's tell them that OF is going to be equal to OC minus OC, right? OC minus FC, because I mean FC is 11, this is square root of 72. Here you can actually just write it like this. You don't have to get a decimal or anything. But maybe before you write this, you could say that FC is equal to GC, which is equal to square root of 72. I mean, this is all just been proven already. So OF is equal to this number here. So in our right angle triangle, the one that looks like this, we have E here. And here we have a 90-degree angle. This is 7. This is now 11 minus square root of 72, right? Now, in a situation like this one, what we know is we're just going to use normal trigonometry now to bring it home. So what we can tell them here is that 10E is equal to opposite over adjacent, and then E is going to be equal to shift this whole thing here. Shift 10, this that we have, and then let's see, shift 10, 11 minus square root of 72. This is equal to close bracket. This is 19.76. 19.76? Why does it seem so unrealistic? Ah, no, it's fine. It looks like a tiny angle anyways. So that's giving us the angle for E. Yeah, so this pre-prelim paper, this pre-trial paper, it's quite an interesting paper. The one thing that I've really spotted is that a lot of these questions are just recycled from other past papers, like literally. But the good news is, I mean, like whatever it is that we've just done here, right? You can hop onto the course website. The link is in the description. Where if, depending on when you're seeing this, right? I mean, you may bump into the all access pass for just 99 bucks. And then you can make a purchase. And then obviously you'll have access to the entire syllabus all in one go. And you will be able to work at your own pace. This is set up in such a way that obviously everything's preloaded onto the website, so you'll be able to go through all these different lessons all at your own pace, you know, as long as you have time, which you always will, you'll be able to go through these online courses. And our main channel, where we have small tutorials on the basics of your different topics for you to like learn the basics of the different topics, that is on our main channel, Bright Young Brains. The link for that is also in the description. See, because obviously the format on our YouTube channel is definitely different from the format on, you know, the website or something like that. So you see, these are the kinds of tutorials you'll find on the main channel, where you'll be able to like learn all that you will need to learn based on the basics of the different topics. Don't forget to subscribe. Don't forget to plug your friends, because I mean, like on this channel you can see there's like a bunch of past papers. There's a total so far, I mean, as of this recording, I mean, there is about 30 something papers. Now, matric maths past papers, matric maths past papers. You see, there's like 34 as of this recording, but obviously Depending on when you're watching this, there's maybe probably more. You see the paper 1 is already there, and then you have all these other papers here from the previous years and the previous months, and on and on and on and on and on. But anyways, I'll catch you in the next video.